Is your dream creating a game but you haven't done it yet? In this course, you will learn the fundamentals of game development. Enroll now in Early Access to get a huge discount and all future updates for free.
Did you ever wanted to create your own racing game but didn't know how to start? In this tutorial, you will learn how to develop a time trial racing game from the ground up, only using Unreal Engine 5. You will develop the base mechanics of the game using blueprints, create the environment of our level using materials and Megascan assets, show relevant game information in the HUD with widget blueprints, create your own sound effects inside the Unreal Engine editor using meta sounds, and learn how to polish the game with a sequencer and package it so you can share it with everyone. The goal of this tutorial is to create the complete flow of a game. This means that you will be able to start the game, play, win or lose, and restart or quit the game. There are no requirements needed for this tutorial, and as always, knowing your way around the editor is recommended but not mandatory. I hope this tutorial is a great learning experience for you, and if you have any feedback while learning with this video, please leave it in the comments below. Also, make sure to subscribe and click the bell if you don't want to miss our next tutorials. With that said, let's begin. Let's start by opening the Epic Games launcher and launching Unreal Engine 5. If you don't have it yet, go to Library. You can choose here the plus button. Here choose the version that you need, in our case Unreal Engine 5, and install it. Then we can launch it. We can go to Games, choose the vehicle template, and give it a name. After this, we will click Create. Here in the editor, we can click here Dismiss. And if we press play, immediately, we already have a car that with the keys you can accelerate, brake, and turn. So we're done. Thanks for watching and see you next time. Whoa, wait a minute. That's not a game, right? What is a game? A definition could be where you're in control of something, you need to achieve a goal, and something is preventing you from reaching that goal. Otherwise, it would be pretty linear, right? And linear is boring. Now, the way that you will be able to overcome those obstacles would be the mechanics. For example, here we could add a jump mechanic. With this little example, we have created a game flow. There is a start, and there is a finish. We can create more levels, add more obstacles, add more mechanics, but the flow of the game will be the same. We need to reach the goal at the finish point. So in order for our template to be a game, we need to add a way to finish the game. In our case, it will be the finish line. When our car crosses the finish line, then we can tell the game that it's finally over. We will make this game a time trial game. You will need to cross some checkpoints in order to stay in the race. And that will be the obstacle of our game. The mechanics, beside driving, will be that every time you pass a checkpoint, you will get more time, so you can finish the race. And that will be how our game will work. Let's start by creating the game mode, which will hold all the rules of our game. Let's create a folder called Racing Game. Inside it, a new one called Framework. And inside it, let's create the game mode. Here we have it. Click. Let's call it GM Racing Game. Inside it, we will define the states of the game. We will have the start of the game and the end. This is done by going to the event graph, right-clicking, and typing custom event. I'll rename the custom event, pressing F2, and call it game finish. I'll also add a new input to know if the player won or if the player lost. Here in the game mode, I want to add the rules that will decide when the game ends. For example, whenever you run out of time. Also, I want to control the different states that my game can have. One of them would be the countdown before the game starts. So I'm going to add another custom event called start countdown. The countdown should wait 5 seconds and then the game should start. So I'm going to drag from the execution pin a delay node. And this delay node will be 5 seconds in duration. After that, I will call the game start. Right now, nothing is calling this countdown, so in order to use it, I need to call the start countdown when the game begins. So I will look for the event begin play. If you don't have it, you can search it by right-clicking and type in begin play. And here it is. For me, I'll just drag and drop from here and call the start countdown. I want to test if my game states are working, so I'll add some print nodes so I can know that these events are being triggered. Now I want to test them. So I'll press play. No message is shown, so I know that my game mode is not being used. I'll go back to the map, and here in the map, I can check which game mode is being used. I can go here to blueprints, here project settings, it's showing me that the game mode that we're using is the vehicle advanced game mode. Right now this world is not overriding the game mode, but we could here select the game mode that we just created, and that would override my vehicle advanced mode, and that was created in a new game mode, excuse me, here, like this. And if I press play, now it says start countdown. But we are not seeing the vehicle. Let's remove the override. And now let's open the project settings through here and select the game mode that we will use by default. We can do it through here, very simple. Or we can also go to Edit, Project Settings, go to Maps and Modes, and here in the default game mode, we have the racing game. When we press play, our logic is working, but we are not seeing anything here. It's because the game mode also defines the default classes that we are going to use in our game. So let's go back to our game mode. Let's go to class defaults. Here in default pawn class, I'm going to select the sports car. And in the player controller, I'm going to select the vehicle player controller. With these two classes selected, I'm going to press play and see what happens. Now we have the car and the HUD that we previously were seeing. This happens because the pawn class is the representation of the player inside our game, and the controllers is the brain. In this case, the inputs of our player. Let me fix this to just say countdown. So now we have an state, kind of an state machine, where it begins with a start countdown, 5-second passes, should be 3, and then the game starts. Here we will have logic, like for example setting up the timer, and when this timer ends, the game should finish. And we should really do that now. Like I said before, the game mode is being used to set up the rules of the game, rules that affect the state of the game. So here, I will create the timer, game start. I'm going to set the timer. And here, I will set timer by event. This timer does not need to loop, so this will be false. How much time it will be at the start? For now, I'll just set it up as 10. Now, something that I would like to mention is that it's not a good idea to have floating numbers. This in programming is called magic numbers, that are just numbers that are explicitly set. If you come back to a project after maybe 2 months, you will be wondering why this is 3 and this is 10. So it will be a good idea to use variables to store this information. To create a variable, I'll just drag and drop from here and promote it to a variable. A variable is just a small box that's holding information. This information can be of different types. And here in variable type, in the details panel, we can change the value of the type. Booleans store true or false, floats, numbers with decimals, integers, numbers without decimals, and we have many more that we will talk later. Here, this variable is not very useful, this name. So let's change it to countdown duration. And it is even better if the name is more explicit. For example, start countdown duration. Again, I will create a variable for the timer and call it start timer duration. After creating these variables, I want to set the default value that is already set, but let me check. Let's press compile. And now, here in the variables, I can see the actual value of them. In order for me to test this, I'll change the start countdown duration to 1, and I'll change the start timer duration to also 1. Here we have a little compilation error because there is no value in the pin call event. So we need to connect an event to this timer, so when it finishes, then the event connected will trigger. Whenever this timer finishes, we should lose. So I will create an event that I can connect to this. I call it lose out of time, just in case we have more ways of losing. Now to connect it, we can just plug it in like this. And whenever I lose, and it's because we are out of time, I'll just call the game finish and tell it that win is false. If we would have won, then this should be true. And here I'll just put another text. And in order to say that we win or that we lost, we're going to do something called a select. I'll drag from here, type select, and when it's A, this is win. If it is A, it means it is true. So if it's true, then you win. If it is false, you lost. Or well, you lose. Perfect. Now let's try it. Let's compile, save, and play. After 1 second, the game has started, and after 1 second, I lost. So it seems that this is working. If for whatever reason we win before we lose, we need to stop this timer. We need to have access to this timer in order for us to stop it. So we need to promote it to a variable. These are different events. If I try to access this timer, I'm not actually getting the same timer, I'm creating a new one. And it's connected to the same event, so I'm overriding the timer. So this will not work. We need to promote it to a variable, and let's call it time remaining time. Then if we need to stop it, we can get a reference from this variable and just clear and invalidate the timer. So I'll create a new custom event called win. And I also given the reason why we won. I'll connect this. And I need to call the game finish. We'll set up the win as true. And now we can call this custom event somewhere. And we can tell the game to stop the timer and then call the game finish, so we can print in our screen that we won or that we lost. We already tested that this worked, so let's change the values of the countdown back to 3. The start timer duration maybe to 10, we can later change it. And with this, the rules of the game has been set. We have some states of the game and how we can finish it. We need to call this win event, otherwise we cannot win. So let's create a blueprint called checkpoint, and that blueprint will let us send a message to the game mode. Let's open the content drawer. Here in racing game, this blueprint is not part of the framework, so I'll just create another folder called checkpoints. Inside it, I'll create the blueprint. I'll select an actor, and just as a refresher, an actor is whatever object that I can put inside the map. Let's call this BP checkpoint. Open it, and here is the blueprint editor interface. We skip it over in the game mode, but it's because in the viewport we won't be able to see anything. Here we have a viewport. In the viewport we will see all the components that this blueprint is holding. We can add components, for example, let's add a cube. And by selecting a component, we can modify its properties here in the details panel. We can change the location, either by these properties or by using the gizmo here, this one. We can reset the property by using this nifty arrow. And well, we can access the viewport the same way that we can use it inside the map, which is with a click. Holding left, we'll move it like this. Holding the right click, we'll move the camera around. And you can get like a FPS control of the viewport if you hold the right click and then move the WASD keys. Also using Q and E to go down and go up. I need a checkpoint, so I want to make this cube into something that can look like a checkpoint. For that I need 2 cubes. And here, because my cube was selected, the other cube was added on top. What you need to take in consideration whenever you're working inside of blueprints is that the child component will follow the parent's movement. For example, if I select the child and I move it around, nothing happens. But if I move the parent component, then the child follows it. The same is with the scale. If I scale one, then I scale both of them. I'm going to use that property and first unparent them. I unparent them by holding my mouse and dragging them up top. Here, you will see drop here to detach cube from cube 1, and now they are detached. But take in consideration that my cube still maintains the properties change, but now in a world scale. So for example, if I again parent the cubes, I scale this cube like this, and then unparent the cubes, then the scales are also safe. So I'll just reset the scales on both of them. And what I'm going to do is click on the default scene root, add a scene component, here, scene component. This scene component will be the parent of both of these cubes. Why? Because I want to use the scene component to scale them, but only upwards. So I just need to move the cube 50 units up in both cases, and move them around a little bit to the side. Something like this. And the same for the other cube. Yeah, minus 250 and 50 in C. Now, this scene component, I will be using it as a parent, just so I can scale in C and it will go upwards. 4 is fine. And now this is my checkpoint. Compile and save. We have now know how to use the components, add more components, move them around, modify them here in the details, and every component will have their own properties that we can modify. For example, here in this static mesh, we have static mesh and we can change it around, but let's not do it. Then the blueprint beside the viewport has a construction script that we will be using it later on. This code runs before the gameplay is executed. And then we have the event graph that we already know how to use it. In the event graph will be most of the code and most of the features that we will be implementing in any type of game. So let's continue. Here in the viewport, I know what my cubes are looking, how they are, the vibe that they are giving, but whoops, it would be a better idea to know how they are looking in the map and see the relation in the size with the car. Let's go back to the vehicle example map and put the checkpoint here. I'll just rotate them and press play. Now it's a little bit small, so I will increase the distance and also I'll change a little bit of the rotation. Why? Because usually when we are talking about the forward of any type of actor, by default Unreal takes it as X positive. Here it is X positive, but in my case my cubes are not like facing forward. We can rotate this scene or we can move the cubes around. In my case I'll just rotate the scene. And here in the cubes I'll move them a little bit farther apart, minus 500 and 500. Let's compile, save, and well, whatever I modify here will be updated in my map. So I need to rotate this again, or I can just reset the rotation here. Now that looks more like a checkpoint that we can pass through. Perfect. Now I want to do something when my car passes through this checkpoint. So I need a way of knowing when did it pass through. Here in the blueprint checkpoint, in the viewport, in the default scene route, I will add a box collision. This is another component, very common one, that will help me know when something collided with it. Here I can change in the details panel the box extent of this component. And well, let's just type here in X 30. In C, we will use 200. In Y, 500. And 30 in X. Should be fine. And let's position this at 200 units in the Z-axis. Now that we have placed this box collision, we want to get an overlap event. We should really check the collisions of this box by going here in the details panel, searching the collision category, and making sure that it's overlapping all dynamic. With this, we are bound to get the actual event when something dynamic overlaps this. And we can later on determine if that's a car or whatever else it could be. So this box will be used as a trigger. To get the overlap event, we can right-click, add event, and begin overlap. It's also here in the details panel, here in events, begin overlap. If we click plus, it will be the same thing that we are doing right now. This event will trigger every time we overlap this checkpoint, so we can create a little print string, press play, and see if something happens. And it says, hello. Perfect, so this is working. Now, we want to tell our game mode here that we are winning the game. So we need to communicate between these two blueprints. For blueprint communication to happen, one blueprint needs to know the other. Either the sender knows the receiver or the receiver knows the sender. In our case, the checkpoint will know the game mode through a reference. And a reference is the way that most communication between blueprints happen. So to get a reference to the game mode, we can just right-click, type game mode, and here you will get game mode. With this reference, we should call the function, or well, the event that we created called win cross the finish line. But if we try to do that, we won't find it, because this reference is just a game mode based reference. It's not a racing game reference. So we need to translate it. And this translation is what it's called a cast. And we need to cast it to our class. Now we know that this game mode reference, which is a generic game mode that already came with the engine, we want the specific class called GM Racing Game. And from here, we can get the win cross the finish line. Now if we compile, save, and play, the content starts, the game starts, and if we cross the finish line, it says you win and hello. And after the 10-second passes, we shouldn't get any type of message because we have already stopped the timer. So this is working. The only thing about this, and I'll get rid of the hello print string, is that if we had more than one checkpoint, it's still triggering the winning. And it's because every time one of these checkpoints are overlap, we are telling it, hey, you need to run the win cross the finish line event. This type of communication right now is a direct communication because we are casting the game mode and we know exactly how the function is called here. It's the most basic type of blueprint communication, but in this case, it is not the most appropriate one. We want to have many checkpoints, and every checkpoint can get crossed. So we want to change the approach that we are using here. We are going to do something very similar like the begin overlap event inside the trigger box, because every time the checkpoint is crossed, I want to trigger some event. The way that we can do this is through another type of blueprint communication called event dispatchers. We can find our list of event dispatchers here, and right now this blueprint does not have any. So let's create one. And I will call this onCheckpoint crossed. Let's compile. And with this existing event dispatcher, we need to call it somewhere. In our case, I want to call it here. And I want to call it only if the racing car crosses the trigger box. So here I will delete this. Drag and drop here on checkpoint cross. And in this case, I want to call it because I want to trigger this. We can connect it like this, but if we wanted to check that we are overlapping a car, we can get here the other actor. In this case, this pin overlap component will be the trigger box. The other actor is the other actor that overlapped that trigger box, and the other component is the component inside the actor that caused the collision. So here, in order to make sure that it's our car, we can cast it. But we need to know the class of the actor. So I'm going to open the car. The car should be in the vehicle template, blueprints, and sports car. I'm going to open this, and here I see the parent class, wheeled vehicle pawn. So this is the class that I will use. So here in the checkpoint, other actor, cast to wheeled vehicle pawn, which is the same one. Now, if this is true, then we can call onCheckpoint cross. This is a simple validation for now, but it will work for us. If we compile and try the game, nothing will happen. Why? Because this event dispatcher is being triggered, but nothing is hearing that trigger, nothing is registering that trigger. The way that event dispatchers work is very similar to a YouTube channel. Here you have the creator. This creator will upload videos. Here's a video. And whenever this creator uploads the video, notification will go out to only the subscribed users. If no one is subscribed, no one hears about it. The same way, if no one registers our event, then nothing happens. In this example, the event that will be dispatched is the upload of a new video. Let's say that someone else subscribes to the channel, and let's give it a cool hat. Now this person, whenever the creator uploads a new video, will receive a notification. The fact that this person received the notification doesn't mean that something will happen, because they can decide to ignore it or to watch the video. But the event was dispatched and notified to the person that was watching or that registered to be subscribed to the creator. There could be more than one subscriber, and let's give it cool hair here. And this will mean that this creator is effectively communicating from one to many. And it means that the sender of the message does not know the receivers of the message. Only the ones that are receiving the message know who the sender is. And it's exactly the same in blueprints. So let's go back. And here, this blueprint is the one that is sending the message. So the job here is done. The one who is receiving the message will be the game mode, because I want to trigger this event whenever the line is crossed. So what I need to do here, because this is the class that is receiving the message, is getting the references of the checkpoints. The way that we are going to do this here is before the countdown is started, we are going to have to set up a little bit of stuff. So I want to start the countdown after all the setup is done, so let's create a sequence node. And this sequence node will be very helpful for organizing our nodes. First, I want to get all the checkpoints that are in my map, so get all actors of class. The class will be blueprint checkpoint. And for each checkpoint, I want to do something. Now, each checkpoint should give me time, but right now I'm not creating that mechanic, so I'm going to leave it by now. I just want to have one of those checkpoints be the finish line. So I need to know that information, and for that I need to store it somewhere. So here in the checkpoint, I will create a variable called isFinish line. Compile, save, and by default it will be false. Now, I don't know which checkpoint will be the finish line, so in order for me to change it inside the map, I need to make this variable instance editable. What is an instance? Well, first let's compile and save. And if we go to the map, we will see that we have the same type of blueprint here. But this doesn't mean that they are separate entities. I mean, they are, but they have a common ground, which is the blueprint checkpoint. Whenever where's my checkpoint? Let's right click, browse asset, here it is. Whenever I drag and drop my checkpoint, I'm creating another instance of that blueprint. And because my variable is instance editable, I can modify it by instance. So this could be the finish line, and it won't mean that this one is also the finish line. If I change this value in the blueprint, then it will affect every instance that it's out there in the map. So in my case, and I don't need this sport card, in the game mode racing game, I want to check each checkpoint. And when I find one that is the finish line, so here I'll get the element that is being looked at. I'll get the finish line. And if this is true, we can use if, or it's also called branch. We can divide the execution flow. And now we can go true if this is, well, true, and false if this is false. If this is true, I want to listen to that event dispatcher. So what I'm going to do here is array element, and I'm going to type the name of the event dispatcher. And here I'm going to bind it. Bind event to on checkpoint crossed. Now I can connect this to an event, and whenever this is triggered, the event will be executed. The event that I want to use is this one, the win across the finish line, but it makes a mess, right? So I'll disconnect this by holding Alt and click, and here I'll just type create event. Here I'll select win. Where is it? Win cross the finish line, and now it's connected. Now every time this checkpoint that is the finish line is crossed, then I will execute the win cross the finish line event, because this bind node is making our class listen to this event and triggering this win cross the finish line event whenever it gets called, which is here. That's why we are calling it. So let's try it. Let's press play. I crossed the first checkpoint, nothing happened, the second, nothing happened, and the third, you win. Now, this implementation is assuming that there will only be one finish line, but if you manage to check this one, then both of them will get registered. And now I see two win messages. It's just something to take into account. Now our game has a start and a finish. We only need to worry about the obstacles that will be stuff that will be added to the map later on, and the mechanics of the game. In this case, the mechanics, the most basic one is driving. The second mechanic will be to get extra time from these checkpoints in order to not run out of time and lose the game. We will be focusing now on that driving mechanics. To tweak that driving mechanics, we need to learn a little bit more about the vehicle that we can find here in vehicle template, sports card, and these are the vehicle assets that the class will use, like the torque curve and the wheels assets. If you want to do a deep dive on how to customize your vehicles, I recommend checking out this video by the good people at Unreal Engine. This video has a lot of chapters and explains a lot of the functionality that you can get out of this plugin. The Chaos vehicles come with a lot of setup if you want to import your own vehicles, and also a lot of setup to get them feeling like you want. Here at the engine, I'll show you the modifications that I did. The first one is in the wheels. I'll open the front wheel, and here I will change the friction force multiplier to 4 and the max steer angle to 50. I'm doing this because I'm not liking the way that the car is steering right now, so I'm giving it more friction and more angle. Also, in the rear, I'm changing the friction force multiplier to 4.5. Those are the setups of my wheels, so I will close them. I will open the car, and inside the car, I will make some tweaks. I want my car to feel fast. And there are a lot of things that I can do in order for a car or something to feel like it's moving faster. One good trick to make the movement feel fast is in the level design. For example, if I press play and start going in this direction, I'm going at 100 something, but I'm not feeling that fast. But if I have more of these columns here, and I'll duplicate more of them, I'll select the 4 and then I'll drag to duplicate more of them, then by the only fact that we have something in our peripheral view, it will start feeling like I'm going extremely fast. So even though we didn't make any change to the car, the level design does help a lot when trying to convey the feeling of going fast. Let's go back to the car. And now let's change stuff that will help me a lot in making this car feel fast. The first one is the camera lag. We will go here to the spring arm, and in the viewport we can see what's happening. We have two cameras, mesh, and I will be working only with the back camera. Here in the spring arm, if I select it, I will have something called camera lag. And this camera lag, if we enable it, by default we have a camera speed of 10 and a lag max distance of 50. If I press play, I will see how the camera starts losing the car. And if I increase this distance to maybe to 200, I can also feel that it gets more lost. The settings that I'm going to use for the camera lag speed is 20. The rotation lag speed 2. And the camera lag max distance will be 1. And we will see why am I setting up this value as 1 in a minute. Let's go to the event graph. And in the event graph, I want to modify the camera lag whenever my speed increases. So here I will search for the tick event. And if you can't find that event, you can search it here in graph, event graph, and event tick. Right now, this template already comes with this car and some things are being done here. If this changes in the future, then I'm sorry that I can't update the tutorial dynamically, but in the comments below, probably I'll put an author's note saying what the changes were. In the tick here, what I want to do is check the speed of my car. Here I know the speed because it is being showed in this hat. And the way they are calculating that speed, if I try to search for it, here in blueprints, we have a vehicle UI, which is a widget blueprint. This is UMG, the Unreal Motion Graphics editor. And this let us create HUDs and interfaces inside Unreal. So this has two parts, the designer, which is the actual interface, and the graph, which can drive code on it. So here, I want to know how the velocity is being set up. So update speed. And here I know that, well, it's checking if it is miles per hour or kilometers, is doing something with these magic numbers that I don't make many sense to me. But the way that this is being used is we get the speed, it's multiplied, and this multiplication is giving the actual value. So I'll just copy and paste this to my sports car. Here, I'll also create this variable. By default, it will be false because right now I'm seeing it. Well, let's compile to be able to see the default value. Right now I'm seeing it as kilometers per hour, so this being false would be alright by me. I need to get the velocity, and to do that, here in the vehicle class, it will come with a vehicle movement component. I'll drag and drop it and get the forward speed. We can get the speed in kilometers or in miles per hour. So I'll get the speed in kilometers and multiply it by the numbers that, well, Epic gave us. And this will be the actual speed. Let's print it. Because I'm in the tick, if I just print it like this, every text has a duration of 2. So it will fill up my screen with the speed. If I want to avoid that, I can set up the duration to 0. And now I have one clean value. And yes, it is reflecting the actual speed that my HUD is showing, so I think it's okay. I'll delete this. And with this value, what I want to do is check if this value is greater than maybe 80 kilometers per hour. Then I want to set in this spring arm the value called, where is it? Camera lag max distance. So set camera lag max distance. And I'll be using again the select node, because if this is true, let's use a select node for a float. Select float, pick A. If this is true, then I want the camera lag to be 10 distance. And if it isn't, I'll just set it up as 1. If I connect it like this, then whenever I cross the 80 value, well, the 80 kilometers per hour value, then our camera lags is making a bit of a jump. To avoid that kind of jump, what I'm going to do is interpolate to this new value. So in the camera lag max distance, I'll type interp, and here we have a float interp 2. So I'm going to choose this one. The current value is, well, I need to get it from the spring arm, so get camera lag max distance. The target one is the new value that I want to use. The delta time, I can get it from the tick. And the interpolation speed, I want it to be very smooth, so I'll just put 0.5. And well, I'm going to organize this. Let's press play and see that it is truly working. And now when I hit 80, the smoothness is very strong. If you want to see a noticeable change right now, I can put it to maybe 400. And it should be able to be picked up like this. But trust me, I just try with 10 because we will still be adding some stuff. Now I'm going to arrange these nodes and we will continue them. And that's it. Something that I sped up here is this reroute node. It's very useful for organization of the wires. You can create one by double-clicking a wire and moving it around. Or you can right-click and search for reroute, and it should still work. Now, we have this camera lag set up. What I also want to set up is the FOV. If we go to the back camera, we will find a field of view property. If we change it around, for example, 140, then we can see how it's affecting our camera. And this type of camera makes stuff look very fast. So we are going to change this field of view, and let me return it to 90. Depending on the velocity that we are reaching. Again, I'll use the same boolean. If our kilometer per hour reaches more than 80, then we will increase the FOV. So I'll get the back camera, set field of view, and here I will connect it. And again, I will need to interpolate the values. The current value, I need to get it from the camera. So let's get it from the camera. And this field of view, the target value, again, I will use a select float. Connect it exactly the same. And here, the A value will be the 115. This is the value that will be changed when we are going very fast. And the normal value should be 90. Delta speed should be the same one. Again, reroute node by double clicking, and the interpolation speed should be again 0.5, so these two matches. Now with the set field of view, note there, when I reach 80, I should be able to get a nice deformation in my camera. And it should start making it feel a little bit more faster, even if we don't have those meshes at the sides. So even by driving around here, we can see that the camera starts slipping out of the normal distance. Great. The last touch here in the driving mechanics would be to add a little bit of camera shake. To add camera shake, whenever we are going fast, we need to create here a component, and let's call it camera. Well, it's called a camera shake source. This camera shake source will receive a camera shake asset, and we can create one here if we don't want to use these ones that are by default. So let's click on plus. Let's go to my racing game. Here, I'll create a new folder called camera shakes, and inside it, I'll call this camera shake vehicle, well, maybe fast vehicle. Save it. And now a new asset has been opened. Let's compile it, save. Here again, we have the camera shake source in the sports car spawn, and it has been set up. The way that we are going to set it up, and you can play around a lot with these type of patterns, I'm going to choose the purling noise, and we need to define a little bit of these properties. The ones that I'm going to touch is the location. Open the X, Y, and Z. And here in X would be 0, because I don't want the camera going forward and backwards. I only want for the camera to go side to side. So in Y, the amplitude will be 70. In frequency will be 3. And in Z, the amplitude will be 50. And the frequency will be 5. This means the amplitude is just the amount that the camera will be moving side to side or up and down, and the frequency is how fast. The more value the frequency has, the faster it goes. Rotation I'm not going to use, FOV I'm not going to use, but timing I will. If you put 0 here, it will be an infinite amount. If you put 1, it will be 1 second. Now, if you put 0, for some reason the blend-in time and the blend-out time don't work. So what I'm going to do is just put maybe 3000 seconds, just so I can get a good blending time of 8 seconds and a blend out time of 3. Otherwise, this blend in and blend out time of the effect won't work. Let's compile and save, and we need to activate the camera shake here in the sports car spawn. To do that, I will use the same comparison here with a reroute node, and I will be doing a branch. With this branch that I need to connect here, something like this, and if you want this to be straightened, we can select both of them and press the Q key, or right click and straighten connection. So when our things are triggering here, we want to start. the camera shake source. And when this is not being triggered, we shouldn't play the camera shake source. So here I need to stop all camera shakes. I don't want them to stop immediately, so the blend out time will work. So let's remove this and we can put it like this. If we test it, maybe things will get a little bit out of control. And it's not subtle enough. It's very noticeable. Why? Because we are telling it to start multiple times. We only need to do this once. So let's use the node call do once. We want to start open, and when this is completed, it will get closed. So we need to reset it whenever we stop the camera shakes. So here, before stopping all camera shakes, what I'm going to do is add another sequence node. And first we will reset it, and then we will stop the camera shakes. With this, let's test our car. And whenever we hit 80, the camera shake should start going in hard. And it is subtly now, like making it that way, it's more believable than just shaking the camera violently up and down. That if you want to do that, you are welcome to. You just need to go here in the camera shakes, remove the blend time, and well, increase the amplitude here, and just press play and try to see what happens now. Yeah, let's just Ctrl C everything. Yeah, that's how it was. Compile, save. And now our driving feels a lot better. Now that we finished the driving mechanics, it will be a good idea to check out the checkpoint and add the extra time that we can gain when we cross the checkpoint. I'm gonna close this camera shake. The UI, for now, I will leave it there. Let's go back to the game mode. Here in the game mode, we already have a way of knowing when we are crossing the checkpoint, but we are only binding this event whenever the checkpoint has been marked as the finish line. That in our case, if I remember correctly, there are a lot of checkpoints here that have been marked with the finish line. Here, true, and because I duplicated it, then all of them are marked. So yeah, I believe we can select everything and remove the finish line. For now, let's just put it at the end. For sure, I will change this later, but I just want to have only one finish line. Okay. Now, let's go back to the game mode, and whenever it is not the finish line, we should add some time. Here, start timer duration. We know that we start with 10 seconds. Right? Yes, and this is the countdown. Perfect. So what we can do is create another one of these events, bind it, and instead of being win cross the finish line, could be just add more time. And it will be the same thing that we already done here. And in our custom event, we could add more time. Now, this would mean that the time that I'm going to add here will be the same always. And that's not exactly what I want. I want to know how much time do I have inside the checkpoint. Or well, if I explain it better, I would want to know how much time that checkpoint will give me. And I want that time to be able to change per instance. So the first thing we need to add here in the blueprint checkpoint is add a variable for the time this checkpoint can give me. And for now, let's call it time to give. We will make this an integer. And by default, every checkpoint will give you maybe 7 seconds. Now, the same way we have an event dispatcher to know that the checkpoint has been crossed, we need to create another one that it's going to be pretty similar, but not exactly the same. So this one will be called on checkpoint crossed, and we're going to add at the end with time. And I didn't, oh yeah, it is. Okay, perfect. But this event dispatcher, I need to know this time to give. So I'm going to first compile, and then I will add an input here in the details panel at my right side, and that's the integer called, well, time to give, or time to add. That probably is a better name. And it doesn't matter if this name is the same as this one, but I'm just changing it so it's just more understandable. And now, not only am I going to call the call on checkpoint crossed, but also the call on checkpoint crossed with time. And here, the time to add will be time to give. And in order for this variable to be editable per instance in the map, I'm going to make it also instance editable. Compile and save. So here in the map, if I click, I can make it a finish line, and I can change the time to give. Now, what we just added means that if any other class binds to both of these events, then it will get a duplicate dispatcher of the event. So we just need to take that in consideration whenever we are using this. In our case, here in the game mode, we are already checking that if is the finish line, then we only need to get the event dispatcher that doesn't have the time, because we really don't need the time. If it's false, I will do the same thing. Bind event on checkpoint crossed with time, that it's just up top here. Oh, oops. And here I'm in the false pin connected to here. And we also need to create an event and connect it like this. Now, you could have only one event dispatcher, one called, checkpoint cross with time, and it doesn't matter. We can have it also here, and we will get the time. And if this function doesn't use the time, well, nothing would happen. But I like to have a clear distinction of the different functionality that I could have. Okay, so here I'm going to create a matching event. And this matching event will come with the same signature. And by signature, I mean the same inputs. So here it will be crossed a checkpoint. Because for the game, well, it's just that. We are crossing a checkpoint, and we will add some time. Yeah, and we can leave it here for now. Now, when I cross the checkpoint, I want to add to this timer. So what I'm going to do is create a function. There will be many cases where you can use events and you can use functions. Just so we are very clear on which are the main difference of these two types of ways of adding functionalities, the events are not guaranteed to end at the same frame that it is called. For example, I could add a delay node here, and this will mean that whatever code I put here, it will be executed after this duration. So if I cross a checkpoint, this doesn't mean that I will get all the code that I put here run or executed at the same frame, which is why I cannot get a return value from the checkpoint, from the events, but I can get a return value from the functions. Here, if I select my new function, I will have inputs and I will have also outputs. Because whenever I run a function, I have the certainty that whatever code I put here will be executed in the same frame. And here, if I try to put a delay node, I won't be able to do it. These are audio effects delayed. It's not a delay node. So apart from that and a little other small differences, sometimes you can use functions or events interchangeable. And it's just a matter of design. How do you choose to use a function or how do you choose to use an event? In my case, when I'm manipulating data, for example, this start timer duration, I want to add something. I'm manipulating the data, I'm reading data, writing data. I prefer to use functions because I know that whenever I call that function, it will be done in the same frame. Okay, so here, this function, I'm going to get the start timer duration. This function will be called add time to, could be to timer, maybe. Add time to timer. As an input, I already put one here, and I'm going to make it an integer, time to add. And here I'm just going to add the start timer duration with the time to add. Oh, another given extra functionality of the function is that whenever you have an input here, and I'm going to compile just in case, is that sometimes it will be very messy to use these nodes, this input node, because the code could get a lot bigger, right? So you can call these inputs like they were local variables. What do I mean by this is that you can type time to add and you can get a node like this even though you have not created this variable, because this node is exactly this input. So that's a way that you can keep your code cleaner. Okay, so I need to save this value, and let's save it here. You can hold Alt and you drop the set. I'm not sure if I mentioned that already, but just in case. And this is how I'm adding time to my timer. If I go back to the event graph, this cross checkpoint should call my add time to timer. And just like that, we have added more time to our timer. Now, I want to know the value of the timer. And for that, it will be a good idea to have a little UI on top of it. So we know exactly how much time we have left, right? It's a good idea to have one. So that's what we are going to add now. So let's go back to the hat. Here it is, vehicle UI. If you lost it, you can search it in the content drawer. You can click on content and type vehicle UI. Here it is. And we already have some components. Well, in this case, they're not called components, they're called widgets. So I'm going to create a new widget. Well, I will use the widgets that are already here. So we can have our time here also. So first, you can just drag the text and move it around. Now I just saw that this is an overlay. So I will need to put my text here. And yeah, that's pretty much it for now. I will later add some padding that it will be a good thing to have. Just like this horizontal box has. So 32, let's just keep using 32. Now, I want to have my text be like, oh, time remaining here, and the numbers here, right? So I need to organize it vertically. So a way to do that is by adding a vertical box. This text box needs to be inside a text vertical box, and we can see the use case of a vertical box here. Gear and the label. And you can see how we can arrange, and let me zoom in, we can arrange the elements using this. And the same with here. And this is inside a horizontal box because it is being arranged horizontal. So thanks to these panels, that we can find them here, we can organize our UI very cleanly. And I'm going to do just that. I'm gonna here in my hierarchy panel, and just to break down very simply, or very quickly, this is the UMG editor, the Unreal Motion Graphic Editor. We have this designer part of the editor. Here we have the palette of all the widgets that we can drag and drop, images, progress bar, etc. And we also have the hierarchy of the overall design. The details panel works exactly the same as in blueprints, where we can click on any of these widgets and change their properties. And also we have this graph part where we can add some code to change the values, right? So for now, text block, right click it, wrap with, and I'm going to choose a vertical box. So now this vertical box is holding my text block. I want to have another text block just like this. So I'm going to drag and drop another text on top of the vertical box here. So now I have the text block and the other text block like this. I could copy the design of how they are doing this. It seems there is some kind of padding here and the gear is different. And the font is also different. So here I'm going to change the typeface to light, I believe it was. Yeah, it's light. And I will change the text to time remaining. Just like that. This text block should be in the middle, so I'll put it in the middle. The same with this one. I mean, if you put middle or fill horizontally, it will be almost the same. Only if your text is long enough. Otherwise, we cannot stretch text with this fill horizontal. So for now, I'll just put it like this. And in here, I will put it on top. You won't see that much of a difference. Now, this text block, I want to increase it a little bit. Not that much. Let's just put 0, 0. And now we can play around with the size. And I'm going to choose 40. Gonna compile and press play just to see our new widget. And now I need to update this value. And there are a lot of ways of connecting the UMG, and maybe this should be a little bit bigger. There are a lot of ways of connecting widgets to data. One of them is just by going here, bind, create the binding, and now I need to choose where to get this value. I know that my time is inside my game mode, and it's called start timer duration. So in this case, I could get game mode, cast it, and my game mode is called game mode racing game. Just connect it like this, and let's get the timer duration. Now this is going to be converted to text, and here we can set up the number of integral digits, maximum integral digits, fractional, maximum fractional digit. Here I will put 0. I don't want any fractions. Or we could have, let's just leave it at 3 for now. Let's see how it looks. And the game has started. This number is not changing, and nothing is happening, right? We can lose because the way we are losing, if we remember correctly, is just a start timer duration, and we have a timer. And because of the way that we are doing things, I made a little mistake. We are not using this value as the variable that is holding the information. We are actually using the timer. So let's use the timer also in the vehicle HUD. So instead of getting this, I'm going to get the timer value. And here I will get the time, well, remaining time, and connect this timer remaining time by handle to this value. Now let's see what happens. The timer starts and we can see the values, right? So let's just put here 0. So we get normal numbers. And now we can see our time change. Now it is working, right? And if I put 2, maybe it won't. Minimum fractional also, I'll put 2. Just so I'm always getting this information. And it is giving me the exact seconds that the timer has. And well, if it's -1, it means that the timer is not working. So that may be an issue later. Now, what is the issue with this type of implementation? As you can see, it was very easy to implement, but I need to warn you, because whenever we are binding, this means that every frame, this functionality will get evaluated and executed. So if we had the time like updating every 1 second and not with a timer, then we will be wasting, like if the game is running at 60 frames, we will be wasting 59 frames. Okay, so every tick, this well, this code that is binded is being executed. In our case, it's fine because it is giving me the exact time that I have, and it's a really neat type of animation that gives me without me doing anything. Makes it like I'm really running out of time and making the game feel a lot more dramatic with the time passing. But in this case, it's working very well. But again, if we didn't have the fractional time, we really wouldn't need to update every tick this number, because it is showing me the same number, right? So it wouldn't be wise to use a bind for everything. In this case it works, but I just wanted to make it clear that not every case will be like that when you're working with UI. This is not a UI tutorial, this is just a racing game, and in our case this works. Okay, so that's pretty much it for the vehicle UI, but the thing is that our checkpoints are not working correctly because I messed up with the implementation. I mean, it gave me more time at first, but it was because the timer was not ready yet. So what I need to do is reset the timer. I need to fix that here in the game mode, and specifically, where is my cross a checkpoint, add time to timer, and this is just a setup value, and I forgot completely that this is just a setup value. So I'm going to get the timer again. I'm going to get the time remaining, get timer remaining time, this, and I'm going to add this value to the time to add. Now, we have no way of adding timer to a currently running timer. What we just need to do is reset it. So that's what we're going to do now. We're not setting this, we are setting a new timer. Set timer by event, and it's the same exact code that our, where is our timer? Here, game start, set timer, this is time remaining timer. It's the same code, but we need to connect it again to the lose out of time. So we need to give this timer the same time it has now, plus the time that we are adding. We need to connect it to the event, and we can do that by using the create event. And now we select the function lose out of time, right? Lose out of time. Perfect. And we do need to set up the variable holding the timer because it is being resetted and put another value. So this one will need to be something like this. Now, this is the way that we are adding time now. We are adding time to the timer by setting it up again and setting it up this value. So now, if we compile and save, let's press play. Let's start for the timer to start. We cross one checkpoint and it adds 7 seconds to our time remaining. And as we cross more checkpoints, we can see how it adds, how it adds more times. And we cross the last one, we reset the time, and there it is. Now I want to tackle something before we pass to the next thing, and that will be whenever we run out of time. I don't want it to show -1. I would much rather it be 0. So let's go back to a vehicle UI, and whenever this value is 0, well, -1, I'll just do something like this. If this is less than 0, I'm going to select a value. So if it's -0, I will let it be a 0. If it isn't, then it will pick the B value and it will be the normal value. Something like this, just so I don't have to see that -1 value. Now we can press play and we can wait a little bit so the timer goes down and reaches the value that I'm trying to avoid, which is -1. So it should stay as 0. Now, the only thing that I don't like about this implementation is that right now, what I did just now, I'm sorry, I need to explain it. I'm playing the game, right? I'm pressing Shift F1 to let go of the mouse. Then I'm clicking here and I'm selecting the object that is currently created in the game. Otherwise, I won't see the nodes running. So this is my problem with this implementation, is that this is being executed even though it is always giving me 0. So well, if I was making this game and well, it really depends, okay? It really depends. If I'm making this game and this interface is being used everywhere, for sure I wouldn't want this to happen because I'm updating 0 for nothing. But if immediately after we destroy this interface, then I wouldn't worry too much about it because I'm no longer executing this. Okay, so if you wanted to change this type of approach is through events. An event-based system is a much robust system because you are in charge of when this is being updated, when should we do the updating of the UI. But there are a lot of compromises that I don't want to make the video longer just for that. And if you want, you can come to our Discord channel and we could chat about it. Okay, so now this is working. Let me save, compile, save. But the fact that this is working doesn't mean that it is a good experience, because whenever I pass a checkpoint, I don't have any indication that the time was added other than the number changing. It should maybe flash, maybe change color, maybe get a little bit bigger, something like that. So that's what we're going to do now. A little bit of polish to the mechanic that we just added. We'll first add the animation and then we will trigger it when the time is added. To add an animation in the UI, we need to go to the designer and we need to create an animation here. Animations, add an animation, and I will call it time alert. This animation, whenever I click it, will enable my timeline. And my timeline, I only need to add, I only want it to go from 0 to 1. But we will see how we do that. We first need to select a track. Well, create a track. And in the track, we will determine what is the widget that we will be affecting. So I do need to select the widget that I want to affect. In this case, the number. Going to go to animations, and with this number, which is a text block, selected, I want to track and select this one. Text, vertical box slot, right? Let's just select text. And it's the same name. So yeah. Now with this, we are adding this track to our animation, and let's click on track. What we want to change is the scale, and the scale is inside the transform. So click on transform, and here you will find the scale. Let's click on the plus sign so we can enter a keyframe, and let's enter a new one in the 0 value. Well, excuse me, in the 1 second value, if I can click on it. Okay, whoop, there it is. Now with that, I'm not seeing anything, but we can first make it grow here at 0.5. And I will make it grow maybe by 2. And 2. And you see that it is getting pixelated, and that's really not a good look. So in order to avoid this, what we can do is make it bigger. For example, this is twice the size, right? So something like this. I'm going to return to my designer just by clicking here, so we are not longer in the animation. Or, well, if we don't no longer want to be in the animation, here I need to click outside of the animation, and now we are not in the animation. And I'm going to increase the font maybe to 100, which is twice the size, right? And with this, now I'm going to first align it to the top. And let's go to animations, select on time added. And here I'm going to change the scale. And instead of starting at 1, it will start at 0.5. And here 0.5. Now it can increase. Well, I no longer want this at 2 value, I want this at 1. And we won't see the pixelation. And this should be at 0.5 also. The only trouble that I have now is that it's a little bit too far away from our time remaining here. So it's not exactly the look that I want this to have. And it doesn't matter what I choose here, because right now we are scaling down. What we do need to do is put it a little bit higher. This is a way of avoiding the text pixelation, but it leaves a little bit to be desired on the design part. So I'll go here to the transform. Where is it? Transform, render transform, and I'm going to move it a little bit. Yeah, -32 or -30 just to be safe. Here in the animation, I'm going to delete these translation keys. Just select it and delete them. And they should be able, and also the shear, that should be able to give me the normal, there it is, the normal value that I want. So that's how we are avoiding the text pixelation in a quick manner, right? So we have this animation. If we press play, should pop out, but also I want to change the color. So here in the text block, there should be something called color and opacity. And inside this, well, I want a key at the start, and I want a key here. That's it, and a key at the end. The key at the end should be white. The key here should be green, maybe. And the color of green should be red 0, green 1, and blue 0. Oh, and I didn't put the correct timeline, so let me, well, the correct time frame. And again, 0 0, red 0, blue 0. There I have it. So now we should have something like this. This is the animation part of our well, of our time remaining. Let's just click outside of this animation. And well, the values should be the same as we left them. Just keep in mind whenever you are changing stuff inside an animation here, that it does matter if you have this animation clicked and the values may be changed, or you have it outside of the animation. And you will see these buttons here to add more tracks. For example, I could add a shadow offset, and that will make it appear here somewhere if this is selected and I add something. And for that, it's better if you just dock it in the layout. Time added, shadow offset, and now you should be able to see it appear. But I much prefer just changing the values here once I know which the values are. Now let's trigger this animation whenever the time is added, right? So I'm going to deselect this animation, and for now I'm going to close this tab, and I'm going to go back to the graph. Right now I'm inside this getText function that is being binded to my text. I'm going to close it for now, and I'm going to add another event at the bottom. This event is a custom event, will be play added time anim, and for this we will get the animation that we just created here in variables, animations, time added, get time added, and play animation. The target itself, the animation is the time added, start time 0 is fine, number of loops 1, 0, loops over and over again. Forward, this is very useful if you need the same animation but backwards, we can put it in reverse. And playback speed is a very important one, because this will let us choose how fast or how slow we want this animation that we created. That's why I created this animation, where is it? Here, from 0 to 1. So whenever I put 2, I know it's twice the speed, so it will be 0.5. And if I put 0.5, I know it's twice slower, so it will be 2 seconds at the end. Okay, with this, we just need to call the play added time animation. So let's compile and save. To call this play added time anim, I need to find out where this vehicle UI has been created. And I remember that it is inside the vehicle controller. Here it is, vehicle player controller. And I'm going to put it here. This vehicle player controller, inside the event begin play. Oh, and by the way, I use Ctrl P to open that little window. Okay, so in the event begin play, this creates the widget. This says that it's, this saves this widget, this hat, into this variable, and then it is added. Now we just need to call this whenever we need it. So I'm going to go to the game mode, which is the one who knows when to add the time. And I'm going to create a sequence node. Or no, it's too much hassle for just one thing. Here, after setting the new timer, I want to get this vehicle player controller, so let's just get it. Get player controller. The player index will always be 0, except whenever you are working in split screen games. Then you could have the different viewports, and this is just the index of the viewport, so it will be 0, 1, 2, 3, etc. For the other type of games, single players and online multiplayers, 0 is okay. Let's cast this to the vehicle player controller. Here we're going to get that HUD reference, get vehicle HUD, and here we will call the play. Where is it? Play added time animation. And that's how we are going to call that animation. Now we will press play. And let's see what happens when we get more time. We cross the first checkpoint. There it is. And again, and again, and again, and again, and again, and again, and again. Now we know how is our... Well, not how. When is our time getting better? Right? It is very hard to miss, actually. So we just polished a mechanic that we already had working, but this increases the enjoyment and the experience. Well, more than enjoyment, increases the ease of use of the experience for any type of gamer. So let's just save everything, and for now let me close all the classes, just so we are in the same track. We have used the vehicle template, which comes with its own game mode, and we created one, and I'm clicking here in the blueprint button, and we can check the current game mode, which is our racing game, and we do not have any overrides here. Otherwise we would need to choose here, select game mode class, and press none. And here in the where it says project settings, again select game mode class and select the one that we created, which is gaming racing game. So with that clear, we can proceed with the last part. The last part of this tutorial is creating a level and polishing the game. I don't want to invest too much time in creating a level because this is not exactly a game design tutorial, excuse me, a level design tutorial. So what I'm going to do is, with my programmer powers, try to make it a little bit more nice. We will use this same track, and if you wish to modify the curves, you will see that this track is a spline, and this spline we can modify it if we go to landscape, and here we can select our splines. So you could modify it if you would like, but in my case I'll just make it look a little bit prettier. For now I will get rid of most of these checkpoints. Let me return to my select mode, and now I should be able to select the checkpoints, and here they are. I'll select all the checkpoints and delete them for now, just for now. Now I want this straight part of the track to be the last part of the track. So the end is like a high speed straight, something like this. So I will put a checkpoint here. And I'm using Ctrl P and searching for the checkpoint. And I'm going to drag and drop it to the map. And what happened? Let me do it again. There it is. And it should be here. Yeah, perfect. Now, I want to replace this material because I want it to be a little bit more realistic, given that our car is a little bit more realistic, right? So, as I said before, this will be the last part of the track, so I'm going to move this player start to the new beginning. The player start is how the game mode will decide where to spawn our default pawn, which in our case is the car. So this player start, wherever it's pointing to, my car will also be looking there. And I know that this player start has some scale change to it, but you could delete it and add another player start. It's in basic, player start, and right now it says bad size because it's colliding with the floor, but once we do that and I'm pressing the end key here to snap it to the track, now it's the same, but I'm gonna stay with the one that was already in the map. If you have more than one player start, then it will be random the place that the game mode will choose. So with that, let's change this material. And for that, I'm going to add assets from the Quixel content. Here in the bridge, I have already saved. Here I should have local, or let me filter it by the hearts that I put in some of these assets. Oh, and I'm not seeing the hearted assets, my favorite assets, because I have not signed in. Let me sign in, I'll pause the video, and we should be back here. Now I can see the assets that I already favorite. Now remember that when you add, when you log in with your Unreal account or your Epic Games account, you are able to use any of these assets here for free in any of your Unreal Engine projects. So I'll go to favorites, and I already have some first surfaces. I have this asphalt road and this damaged concrete that I already downloaded. I'm using the medium quality. I didn't really feel the difference with the high quality or highest quality. Medium quality is fine by me. So I'll just select this asset. Let me go back to favorites. It's the asphalt road and the damaged concrete. Let's import it, and again, and now we have these two folders. Now, for the asphalt, well, let's use the asphalt road. Here we already have a material, so let's just drag and drop it. There we have it. And for the sides, we will use the other material, the damaged concrete. And there it is. We have now the new track with the new materials, right? I also wanted to change this floor. I'm going to use a little bit of vegetation, so maybe some dirt or something like that that I can add to this floor. For that floor, I'm going to go back to the bridge, surfaces, and I added this one called forest floor. And well, I'll download it. Again, medium quality. I don't really need more than that, and export it. Now we have it here, and I'll just drag and drop it on the floor. Now, if I'm not seeing it, it's because this floor, it's a landscape streaming proxy. So I need to select the landscape and change the landscape material. And I can open this material. And we can here change the surface floor, grid color, etc. So this will make us create a new material. Well, yeah, a new material for this specific landscape. So let's do that. Let's go to our racing game. Here we can add the new folder, environment. Inside it, let's create a material. Let's call it racing landscape. There we are. Double click it, and now this will be fully rough, because I don't want to have to deal with the roughness. I'm not going to create a complex landscape material. And now I'm going to drag and drop the textures that I will be using for this. In my case, where is my Megascan surfaces, forest floor, and here we have them. I'll probably just use the normal. Not so much of this other material. Yeah, let's keep it really simple. Let's start by adding the layer. Blend. And this is not the one that I was looking for. This one is called Landscape Layer Blend. This is the one. For now, I will only have one layer, which is the dirt. Let's call it dirt. Connect this to the base color and connect this one to the normal. Let's just put it like this. Save it. And now let's apply it to my landscape. Select the landscape. Oh, and I'm going to here go back to the material, browse to it, and create a material instance. This will be MI Racing Landscape. Just so if we manage to add some more properties here, it's easier and faster to change them. And now here, in the landscape, let's add the material, which is the MI Racing Landscape. Now, I'm not seeing anything because I need to go to the landscape, and here in Paint, I do need to create this layer information. So let's create the layer info, and I would need to create this one. Weight blended layer. Just select the default folder, dirt layer info, and now we should be able to see it. Oh, and it's entirely my bad, because here in this landscape pieces, we have not set up the correct material. So that's the issue right now. Let's select the correct material. Now we should be getting the information that I was looking for, which is this material that it's looking very nasty right now. So I need to, here in the material, mess around a little bit with the coordinates. And that's what I'm going to do. For that, I'm going to get the absolute, nope, it was the world position. This is the one. I remember it was absolute something. With this world position, I only need the X and Y value. So let's add a mask here. And I just want the component mask, this one. So I'm getting the X value R and the Y value G. That's the only thing I need for these coordinates. Now we're going to do a little division. And the value here will be one constant, or just a constant. Constant one vector. You can also press 1 and click, and it's the same. And I'm going to convert this into a parameter. Convert to parameter. This will be the dirt tiling value. And by default, I want it to be 512. And I will divide this position by this number. And I'm going to connect this to the UVs. So now you can see the result of what we just done. And I need to do the same for the normal. So they match. Now they should be matching. Now let's save. Let's go back to the map. Let's get out of this landscape mode. And we can see that it's no longer tiling so badly, but we do need to up that number. So here in the racing landscape, let's browse to it, and now open this MI racing landscape. I'm going to have it as a floating window, just so we can click here on the dirt tiling value and change it to whatever we would like it to be. Now, it won't matter if we can see it from this eagle's eye point of view, but if we press play and we are playing, then we shouldn't be able to see it that easily. Maybe it was 512 multiplied by 2, and that's more than enough. I'm using values that are the power of 2 just to keep the textures consistent. And again, doesn't matter that I'm seeing the way it tiles, because we won't be able to see it while we are in the car. It will be very hard to do that, especially when we add more stuff to the track. Perfect. Now let's continue with the level decoration. For the level decoration, I will need more of this bridge, well, Quixel assets. So let's just close the material for now. I don't really need it. And I will be using these concrete barriers, maybe even these ones. Yeah, I'll add both. Yeah, both? Yeah, both. So let's add, there's one, and again add, and there's two. I already downloaded them, so it is easier for me to just add them. You don't need to see me download them. So now we have this concrete barrier that first I want to add some collision to them. Right now, if I see the collision, I just double click. This is the static mesh editor. We can click here, show simple collision, and there is none. So I want to add a box simplified collision. Yeah, that's all I need. And here at the right side, let's see the collision setup. And right now it's blocking everything and the project's default, which is fine. I'm going to save it and also going to open the other concrete barrier and do the same thing. Here I know it doesn't have a collision because this remove collision is grayed out. So I'll just box simplify collision. Should be fine. If you needed more something that fits your shape, well, you can delete the collision here, remove collision, and play around with these other settings. Yeah, that's a way that you can make it fit a lot more. But if you have more tangents, more faces, then the computer needs to process more stuff, so I only need a box collision. And in order to feel like I'm colliding with this, it's more than enough. Let's save. And what I want to do is with this one that has a arrow, I want to, put them in the corners. That way, when I press play, I have something to collide with. Yeah, and if I add some trees later on, then I don't need to worry too much about the collision with the trees and all that stuff. I only need to worry about the collision of these concrete barriers. So a way that we can do this is, well, we can manually add the concrete barriers. And where's the other one? Oh, and for sure they are too small. Let's play and check out the... Oh, where did I add them? Oh, there. Okay. I can right click, play from here, and there they are. Yeah, they are definitely too small. This one, maybe twice the size, would be nice. Here, scale. I'll put the lock on it, so when I press 2 here, then it scale uniformly. And here 2 also. Yeah, twice the size is fine. Maybe here 2.5. 3 times. Yeah, that's a lot better. And we could start doing something like this in order for our level to be created, right? If I do that, eventually would have covered all the things in my map, all the corners, all the tracks, right? But yeah, it could be very time consuming. So we're gonna create a little tool that will help us decorate this level with this type of barriers. Let's go to my racing game environment. Let's create a folder called barrier tool. Inside it, I will create a blueprint class. It's going to be an actor because these barriers are actors. This will be a blueprint barrier tool. And inside it, I'm going to create a blueprint that will help me just create straight lines. This is going to be like a first example of what you can do with blueprints to help you create a level faster. So I want to create a mesh here. I want to be as optimized as I can at the start, because optimizing afterwards gets really troublesome sometimes. So if I duplicate a lot of these components, having a blueprint that holds maybe 50, hundreds or thousands of components will be very heavy for any type of machine. So instead of doing that, we have another component called instance static mesh. And this component, I'm going to delete the other one, this static mesh. This static mesh, you can select any static mesh, for example, our concrete barrier. And you see that we are not seeing anything. But it's because we can add instances of this barrier. Now, I don't remember if I can add manually here, rendering instances. Here it is. And it is an instance of this static mesh. And whenever we create another one, and we move it around a little bit, let's just put 100 or something like that. Then, as you see, we are not creating another component. This component is in charge of dealing with the creation of another mesh. And we can drag and drop it to our map, right? Now, if I remember correctly, this should have collisions, and we can test it if we play from here and just try to collide with it, and they do have collisions. So now we only need a way of adding more and adding them in the correct scale. So let's fix the scale first. Let's go back to the barrier tool, and we can close this static mesh editor. In this barrier tool, in the instance static mesh, I'm going to change the scale here. Remember, this one was 2. But keep in mind that if we change this static mesh for our other concrete barrier, then it won't match. So for now, let me just revert this, and we are going to create a variable called scale. And this will be a vector because you can scale it in X, Y, and Z. Now we will go to the construction script, and we're going to drag and drop this instant static mesh. We first want to define which static mesh we want to create. Here is defined like this, but we should be able to change it. So let's set static mesh, and I'm going to make this new mesh a variable. And let's call it mesh to spawn. I'm going to make it instance editable. These eyes are the same as clicking here, instance editable. And this will let me, let's compile, save, that here in the barrier tool, right now that instance, where is my blueprint? Right now this mesh to spawn is none. So I'll just put the barrier there, compile, save it, and now we can see it. If we select our blueprint, if I can manage to select it, here I can search blueprint barrier tool. It's this one. We can change it here also. And we want to do the same thing with the scale. So let's go back to the barrier tool. I'll copy and paste this. Set scale. Set scale. And we can use this set relative scale. It's the same as clicking here and changing the scale here. So let me just, new scale will be the scale. By default it will be 2, right now it's 0. Let me put 2, 2, 2, compile, save, and now we have the scale here. And I did not want to click here, let me click on the barrier tool again. Right. Here we are in the barrier tool. We can change the scale independently and it should work. Right, so now I don't want to add manually these barriers, right? I will go to the barrier tool and here in the instance static mesh, I'm going to remove the current instances. Maybe I'll leave one, maybe just to see where it's being created. And let me replace this mesh to spawn with the other barrier. So yeah, this is the one that I wanted. So here, I'll just go back to the construction script, and the construction script, I just realized I didn't explain it, is part of the script that will run before the game runs. Before anything here in the event graph is executed, this construction script will run. Not only that, it will run every time any property in my game, well, excuse me, in my blueprint, in this blueprint, changes. So I'll just put here a print. This says hello, right? I'll compile, and if I just hop back quickly, it will print hello. If I move the location, it should print hello, and we can see the log here, hello. I'm not seeing it in the screen because, well, our game is not running, right? But I'll just clear this log. I'll move this around and we should have a lot of hellos. I'll clear it again. I'll select again my barrier tool. I change this scale maybe by 3. And this construction script is running because a property changed. I'll put 2 again. And with that said, it's time to create the number of barriers that I will need. First, I need the distance that I want to use to create these, well, these barriers. So I need an endpoint and a finish point. The start, I said an end and a finish. I need a start point and an end point or finish point. The start point is, well, this one. It's just fine as it is. So I'll just create another vector called end point. This vector will also be instance editable, and I will put here show 3D widget in the details panel. Compile and save. This will let us see that there's here an endpoint. And if we click on it, we can move it around. So we can define our endpoint. Now with this, we can create the logic that can help us spawn the needed barriers. Let's go back to the blueprint. Let's go back to the construction script, and this is where the magic will happen. So let's do some magic. We first need to create the instance mesh, just like we did before. Here, instances, add one, and we will be able to see more instances. So we do need to grab again our instance static mesh, add instance, and you also have add instances, but for our case will be just add instance, and we'll just put it here. This asks us for a transform, and it could be in workspace, but our endpoint is in relative space. So if this is maybe, I don't know, 300, it means that our initial point here is, well, this part. And 300 in x would be, where's x? Here's x. Something around here. So we're not going to use world space coordinates. Now we need a transform, and for that we do need to make one. Make transform, and a transform is a location, a rotation, and a scale. Scale will be fine because we are already changing the scale here in the instance static mesh, so let's not worry about that. But we do need the location and rotation, and just by doing this part of the code, we can compile and we will see that we have an instance here. Now, let me just remove the instance, where is it, that I added first. And right now we have two instances, one that it's being added by the construction script and one that we added manually here. The way that I'm going to show this is just by rotating the instance that we're adding towards the location of my endpoint, right? And to do that, I first need to use a node to get this rotation, and this node will be the find look at rotation. Now let's remember that we are in relative space, so the start will be the 0, 0. I can make this a literal, where is it? Literal vector. No, don't want to. Or I can just right click and split and we will get the vector 0, 0, 0. The target is the endpoint, so let's just connect it like this. Come on. There it is, endpoint, connect it like that. By doing this, if we compile and save, wherever we move our endpoint, our mesh will rotate with it. So now we can see that we have an extra instance that, well, it's the instance that we were adding manually here. This one, so let's just remove it. Compile, save, and there it is. Now, every time I move around, well, I move my endpoint around and we have the space needed to create another one, well, I want to create another one. To do that, we need to execute this code as many times as we need. So how will we know how many times do we need to execute this code? Well, we first need to know our mesh, it's not distance, our mesh length. So for example, if I go to the mesh I selected, which is this one, we can see the approximate size here, and it says 304. So we're going to use that, and I know is that because it's the larger number and it's very easy to recognize which one is the largest number, which is x. So I need to save that somewhere. I'll just create a variable because remember, the mesh can change in distance, or in length, or in width. So I'll just put width. And this is not a vector, this will be a float. Let's compile and save. Here in the width, we can type the same value, which is 304. Here it is. And be done with it. Now, we are assuming that we are using the x value. If you would want to make this a little bit more automatic, we can get this mesh to spawn. We can get the bounds. And inside the bounds, we can split this. We can get the box extent. And the box extent in this case will be half the value of whatever you're seeing here. So you would only need to multiply by 2 and you will get the approximate size. Why am I not doing it like this? Because maybe our mesh, instead of being, instead of using the X value, maybe I want to use another one. So that's why I'm not using this type of implementation. That would require for me to content curate the meshes that I'm going to use, but in my case, I'll just set it up manually. I only need to check a number and I only have 2 meshes that will use this, but I'm telling you, you can do it automatically also. Okay, so with this width sorted out, we can now check, right? And first we need to know the distance between the starting point, which is 0, 0, and the end point. So we can check how many instances do we need. So for that, what I would need to do is the end point minus the start point, and then I would get the length. That way, if our point is here and our end point is here, let's say that this is the 0, 0, then by subtracting the start point to the end point, I'm not getting all the distance. I'm only getting what I need, which is this. In my case, the 0, 0 is the start point, so I don't need to subtract anything. I only need to get the length, so I know the value of this distance. And I should probably use another letter, for example D, the distance. So I need to, I'll just copy and paste this endpoint, get vector length, and with this I need to divide it by the width of my mesh. Why? Because, well, I already know this is my start point. Let me just call it A, endpoint B. I know the distance between these. I just want to know how many meshes can I fit. And if my mesh is like, I don't know, half D, then I could fit 2. So by dividing my total distance by the width, then I should be able to get the number of meshes that I could spawn. Now, this is giving me a decimal value, which means that if I have a space for 2.5, it will return 2.5. But I only need integer numbers. So I'll just do a floor operation. The floor means that it will round down the number. If this was 2.5, it will round down to just 2. So now I know how many times do I want to run this add instance. Okay, so let me just move it to the side. And whenever you want to repeat some code, you will be using any type of loop or while operation. In my case, a for loop is more than enough. And here it is, for loop. And now if I connect it like this, it will run the number of times that I say so. Now, right now, this is 2. If I put the first index at 0 and last index at 2, we are not running this 2 times. Because the 0 is the first element, we are running it 3 times. So we will see what happens. I will later on change this to 1. But first, let's see what happens. Compile. And right now seems like it's the same, but it isn't. There are 3 instances here. Now I need to change the location per instance. So the first time it runs, I want for the location to be, well, at the start, so 0 is fine. But the second time it runs, then I don't want the same location, so I need to make some adjustments. The first issue that I need to address is the rotation, because just by adding the width of this mesh to one value, maybe X or maybe Y, won't solve that I want this location. It will probably give me this one or this one, and I want the one in the middle. So to do that, we already know the rotation that we are using for our meshes, so I'll just find the forward vector of this rotation. How will I find it? Well, just get forward vector. With this, now I can multiply the distance and it will give me that distance in the correct direction. So to just do it, and we will later on fix it a little bit, we will just get the width, multiply it by the times that we have here, and this is interchangeable. I can just connect it like this and it will still work. So for example, the first iteration is 0 width, so it stays in the normal place, in the starting point. Then iteration number 1 will be width times 1, so it will move the width of our mesh, and so on and so forth. This will be multiplied, and I need even more space here, by the direction. And this direction is the forward vector. And now we can connect this to a location because we have multiplied a scalar value, a number, by a direction, which is a vector. And that gives us a vector with the magnitude that we wanted. The magnitude is how big the vector is. Okay, so let's compile and see what happens now. And this is what is happening. We're getting our endpoint, and when we move it around, the values change. Now, why is it not a exact fit? Well, because our scale has changed. Let me put the scale back to 1. And now, every time it has space, it's created. And we have another issue, right? Because I'm creating one at half the point, at half the value. There shouldn't be any space here. And if this doesn't kill you, you can leave it there. To me, it's like, oh, it's not exact. I can forget about it, but right now I would really like to fix it. But it would get a little bit more confusing, but still I'm going to do it just to give the complete knowledge. Okay, so first thing first, let's address the scale, because I want to use to scale everywhere. So I need to take that in consideration. Here, when we are determining how many instances we want to create, how many loops should this have, I need to take in account the scale. So before I get the length of this endpoint, I need to scale it up to the proper value. So let me move this here. So to do that, I'll just put endpoint and divide it by the scale. And here we have the scale. So if it's twice the size, then I'm just dividing it by 2. Something like this. Now with that, let's compile and save. The scale should be working the same way. Doesn't matter if it's 1 or if it's 2, right? Now it doesn't look weird at all. Now to address the other issue where here is at half value and it's still like creating one, like bothers me a little bit, so it's a quick fix. Let's go back to the barrier tool. You already fixed the scale. We just need to fix our distance problem. To do that, here, before we multiply this width to our forward vector that I'm going to put like this, and move it to the side, what I want to do is subtract some value like this. And this issue is happening because the pivot point of my mesh is at the center. So I need to take that into account. Here, I will get the width and I will divide it by 2. And I'm going to subtract like that. And let me put this here just so it's a little bit more compact. And that's how we fix the width. Now when we have the space for it, it will be created. Now again, we have a little issue because when we do not have a space for it, one is being created at the 0 point. So again, we have an extra iteration. And that's one of the quickest fixes. We just need to put the first index 1. And that's it. Compile, save it. And now we can select our endpoint and it will work regardless of the changes that we did. And now it's a little bit more intuitive. Now I do not like this gap, and that's why I didn't want to change the width. I mean, I didn't want to use the width that I got from the bound box or the bounding box, because now I can tweak this like I want. So 209 is a fine number, so let's use it. And now what I need to do is, well, look around where we have these straight lines and just move it around. Now we will do something for the curves, don't worry. But for now, this has let us create more easily the barriers for straight lines, and we can tweak around the value scale 3, and we don't need to move around stuff again. Oh, where's the, oh, here, 3. Maybe this looks better, I don't know. I believe I decided 3, or this was 2. Yeah, 2 and 3, this one was 3. So yeah. Now, if I click on the meshes, I'm clicking on the instances. I can click here on this little icon, or just click it in the outliner, and then I can modify the overall blueprint. And 2 was fine, I believe. Yeah, so what I will do now is add these barriers to all the straights in my map and continue with the next thing. So I have used the tool that we made to create these straights of all those parts of the track. And it's very simple. You just need to, for example, get this actor. And let's say that this part is a straight part, then you can just move it here, change the endpoint, and you're done. So I have done that for, well, all the parts that my track has that are straight. In this part, because it's a time trial, this is the end. So you need to check it out as is the finish line. Put it at true. And because we're starting here, when we press play, we have this barrier that doesn't allow us to skip stuff. So that way, when we just go around the circuit, and let me just cheat a little bit, then we will be here at the last straight, full gas, and then I win. So pretty cool, pretty cool. We will disguise this some way or the other, and also we will hide this, but right now we have a good start of our map. Now we need a tool for the curves, and for that we're going to use splines. We are also going to use the construction script for that, and we're going to use this mesh in specific. So let's do it. And again, if you wanted to change the mesh of this blueprint, you can click here, change the mesh to the other one, and there you have it. Then you would need to adjust the width to the value that you would like, and also the scale. So for now, let's just not mess around too much with that, and let's continue. So I need some curves here. Let's create a blueprint that will allow me that. Blueprint class, actor, blueprint, curves, barrier. Let's open it, and whenever we need curves, we will add a component called a spline. Here it is, spline, and a spline is just a curve. You can define the values of the points and the values of the tangents. So we will make our mesh follow this spline. So again, we do need an instance static mesh, because we will add static meshes as many times as the points that we have in the spline. So for that, here, instance static mesh, I will put my other barrier, which should be this one. No. And let me close the barrier tool, the other barrier tool. It's the concrete barrier is the LOD3. Well, so great, these identifiers. Okay, so we have the correct one. We want to add one of these instances for each point that our spline has. Right now, our spline has 2 points. So let's go to the construction script. Why did I close the other barrier? Because we will copy that code, like this first part of the code. Let's just copy and paste it here. because if I wanted to change the mesh to spawn, I should be able to do that. Oh, and I do need the scale. Right click, create variable, scale. The scale this time will be 3 because it's kind of being tailor-made for this concrete barrier, but should be able to change if we want. Now, from the spline, we want to know how many points does this spline have. So I'll just put points, and we can add points, clear the points, get points, and there should be a number of points. So points, get number of spline points. This is the number of times that I want my for loop to be executed. And this is a for each. We don't need that. We need a simple for loop. Now, in the case of the spline, the points, the way they are numbered is something like this. Let's say we have 3 points, and our spline is like this. This is the point 0, the point 1, the point 2. So that's why this, if we have 3 points, it will give us 3, but the index, the last index, should be 2. So I'm just going to subtract 1. There we go. Now, in the first iteration, I want the first point, and I want to get the location, and we can get location. And yeah, the tangent also should be good. So get location and tangent at spline point. Now, point index is this one. Coordinate space, local is fine. And we will add the instance with the instance static mesh component. So let's add instance. Again, we do need the instance transform. Let's just make one, make transform. And here the location, we already got it. So let's use it, compile, save, and let's drag and drop our curves barrier. Now I'm not seeing my spline, but it is here if you just look around it. If we click on the blueprint or any of the instances, we are clicking on the overall blueprint here, but the spline starts there and well ends here. So whenever I move this, we can get the location. So what I'm going to do is put the start. In my case, I want this to look inward, so I'm going to put the start over here. Yes, here. Oops. And I want to change this spline maybe to the other way. Here. Something like that. Yeah, it should be something like that. Now, we can add another spline point by holding Alt and dragging the point. And as you saw, we have the movement. And right now, I made a little mistake because right now we don't want to scale the overall instance component. We only want to scale our mesh. So it just matches here. So let's go back to the curves barrier. And here in the scale, I will put the scale. And I will delete this part. So we have something like this. Let's compile, save. And now our location shouldn't be modified. And I'm going to press F to focus the point. We can do something like this. And move our splines around. Now, what I want to do with this spline, and it seems that I got the direction wrong again, so I'll just create it again. Let's just coarse barrier, delete it. I'll just drag it here. We have a spline point. Where is our spline point? Here. So we can create more of this. Let me select it again and move it like this. Let me just put a little curve so we can continue with the implementation. Spline point here. I'll press Alt and drag it. Spline point there. Again, spline point here. And a spline point here. For now, it should be fine. What I want to do is rotate it towards the tangent of the spline, so we can have a smoother rotation. So here in the blueprint curves barrier, we need to use this information. And to use that information, we just need to plug it into the rotation. We will get the rotation from the X vector, which is fine because that's the one that we are using. So it will be something like this. And let's see how it looks now. Now if I modify one of these spline points, our barriers will try to accommodate themselves. So with that said, let's just delete it again. Put one here. There it is. That's a lot better. Where is the spline going towards? Oh, it's that way. Right? Where's the spline going? That way. Okay, so wherever we move it. I'll select it again and go back here. And I'm holding the shift key and moving it around so my camera follows whatever I'm dragging. I'll need a Nift trick to navigate the editor better. So now we can do this. And again, selecting it again, so I'm moving the overall blueprint. And now it's just a matter of following along. Holding Alt, create a new spline point, and you follow along the track. Now remember, you have access to the tangents, so you can't, well, you can mess around the individual rotation of any one of these meshes, especially the one that will be at the end, because there won't be another point. You won't be able to touch, well, to tweak too much of it. Yeah, so probably I'll just speed up this, or I'll just pause the video and do this part of the record, because as you see, it's time consuming, but it's not as time consuming as if I was just dragging them, dropping them, rotating them, and using them. Also, this is more memory efficient because we are creating instances of static meshes. We are not creating multiple mesh components. So it's really a win-win situation for everyone here. Programmers will be happy. Artists will be most definitely happy. And here, for example, I will mess around with the tangent, the last one, just so it's it fits better. And tweak around a little bit of the distances here, just so the gap is not that noticeable. Yeah, now if I press play, and of course I didn't do the first corner, of course, but here's the second one. It's working correctly. And yeah, we do not have that much variance, but don't worry, we will add some later on. We will disguise our tools. But what I wanted to achieve with this is the collisions of my track, just so I don't get out of the expected zone of the play, of the game, excuse me. Excellent, so now I will add the barriers for all the corners. Now I finished with the positioning of the splines. Now I won't say it was pretty fast, but it was a lot faster than just putting them one by one. And if later modification needs to be added, then for example here I can put this here, hold Alt, and I can add more points between points. So yeah, it's very useful tool. Perfect. So now with that said, I already test the collisions and how it's looking, and yeah, it's working fine actually. I was very surprised. What I do need to add it's the checkpoints, right? For example, I want the timing, and let's wait for the start countdown. Yeah, like, whoops, again. I need to see where to add the checkpoints, right? Maybe here would be a good place to add a checkpoint in this curve here. And where's my checkpoint actually? Here it is. It's a little small. I do need to change that. So I'll just Control E and make it a little bit bigger. And instead of 50, maybe this will be 60 minus 600. Would that be good? No, that's still too small. I can check it out here. Cube. Move it around here. It's like 1,000 something. But something like this would be nice. Yeah, okay, so 1,000. Here. 1,000. And here. Minus 1,000. I need to change the box extent of this one to reflect the change. Should be around here. And that's pretty much it. Yeah, that's fine. Yeah, something like that. And here was my end one. Yeah, should be, can select with this one. There. Yeah, great. It would be a good idea to change the checkpoints, but I'm going to add them as I see fit. So let's play again, and I will test it, pause, test again, try it again, the game again, just so I know that it is doable. Maybe here I could put another checkpoint, and here, yeah, this straight seems like a good place for a checkpoint. Here, rotate it, and a last one here. I just have a hunch that those places are good enough for me. And now it's just a matter of playtesting. There it goes. I need to disable also the inputs before the countdown starts. Or well, when the countdown ends, then we should re-enable the inputs. That's a bad bounce, that's a bad collision. Okay, it shouldn't be too worrisome, hopefully. Yeah, and it's pretty challenging if you're a bad driver like me. Yeah, and yeah, that's actually pretty cool. Now it feels like a game. Now let's decorate those checkpoints. What I'm going to do with those is go here, the bridge, and I'm going to use this Japanese wooden well roof. Yeah, let's make it a little bit Japanese. And maybe something like this wooden lamp, wooden bridge. Let's just use that one for now. I'll open the checkpoint and start replacing these cubes. The wooden something should be 3D assets, Megascan 3D assets, Japanese wooden something, and here it is. Now we do need to reset the scale. Well, the material and also the scale is being modified here. So I'll just reset this to 1. And the way I'm going to use this is, well, first put them in the ground, 0, rotate it a little bit, scale it a little bit also, and just like that for now. Yes. Let's search it again so I can put it here. Reset the material, scale it 1.75 and also rotate it. And the location should be fine, this should be 0. Now if I look at my checkpoints, they will look something like that. We can make something more complex, if you want to call it that, by using more assets, especially more of these type of assets, Asian assets. Could mean, and let's just use this one, download it. We can add more complexity and make it a little bit more interesting. Let's go to the checkpoint again. Let's add to my scene, maybe to this cube. And I'm going to detach it, attach it only to the scene. And for example, do something like this. Now let's scale it up. And we just need to fake that it's not floating around. And I'll just duplicate this, Control D, and move it to the other side. Something like this to give the impression that this is not something. Oh, that one is floating. This one is floating. Like, it's not something normal, right? And this, I'll duplicate it, Control D again, move it to the side, Control D again, move it to the side. We could probably have done this in only one mesh with the mesh editor, but I mean, I'm not using that much of these components. Yeah, something like that. If I press play, should be looking a lot more interesting. And now our checkpoints are a little bit more noticeable, right? So that's another plus for our map. Now we will add some foliage to our surroundings. To do that, I need first these trees. Maybe these ones, maybe these other ones. I will use both. Here's the name, hornbeam tree trunk. Let's add it. And this one is just called that tree. And again, add it. So here is one, the tree, and this one added. There it goes. Perfect. So we have those two. Maybe we can use also these three stumps. Pine tree. And this one, nah, this one no. Don't like that one. Okay, so now that we have these meshes, let me close everything that I don't need right now. Control S and save all just in case. I'm going to go to the foliage mode. And I'm not doing too fancy stuff here in the landscape because, as you see, I won't be able to see much of the landscape. Now, I'll go to the foliage mode. This is my starting zone, perfect. I need to drop some foliage here, so I'm going to drop the pine something. Because this is a static mesh, it needs to create a foliage type of asset, so just click OK and it will be created. Also this horn beam tree and the dead tree. Hopefully they don't clash too much. So now that we have our foliage, if we paint around, we can see that it has been created. And the pine tree, I do believe I'm not liking how it's looking. Now, the density is too much. So let me reduce it to 0.1. And yeah, I don't know if I don't like the dead tree or if I don't like the pine match with the ground. Yeah, the dead tree is not doing it for me. Okay, so I'll just remove the dead tree by clicking the check. We can add them like that. Again, that's too dense for me. So let's just halve it. Well, it's not half, it's just divide it by 4. Yeah, that's better. And now let's select both of these and play around with the scale. Here, minimum will be maybe 2 and maximum will be 5. Now when we paint, we have something like that, which we should be able to see. Yeah, something like that. And it's not too dense. Well, I mean, it's a little bit dense. Yeah, it may be too dense. So again, let's halve this. That's a lot better actually. And I'll just paint. Nope, it's still too dense. My god. Halve it again. And well, if you're reaching lower values here in the paint density, you can also go here in painting and you can select by each one the density that you want, or just select both of them, and here I'll just put 20. Yeah, that's better actually, because I'm going to fill. Let me just undo this. Let me put 10 or 30, excuse me, because I want to actually use some trees, but I don't want too much trees because that could affect a lot of the performance because of the materials that they have. But these are tree stumps, they're a lot simpler and easier to render, so I can populate more of them and the player won't notice too much. Now these these meshes were added by the default map, so maybe I can remove them. Let's go to the selection, select these cylinders and just remove it. We have some ramps here. Again, you can select the folder and remove it. And I should not have done that. Let's select everything and just remove it. Road bumps, we don't need them. And let's go back to the foliage mode and keep painting. Also, you can increase the brush size, so you don't need to paint too much around the same place. And for these parts, would be a better idea to have a smaller brush. And I'm not too upset about this. Maybe this one's too much, but this one actually blends very well with the map. Yep. Now I just need to see in which parts the trees are, well, the stumps or tree trunks are. I believe it's just this part. Yeah, this one. It's really not believable. What you can do here in the foliage is select and modify one by one. This one, I really like the fact that it's like this. Maybe I could move around this. Let me go back to the select mode. Move around this barrier a little bit. Like, oh, there was a tree here. The tree is also working to block our car. And now we have a track with a lot more trees, and here I didn't have that many, so let's paint some. Let's go back to paint. There it is. And having trees very near to our car should give a very cool effect on the fact that we are going faster, because we have stuff going around in our peripheral side. So it can make us believe that we are actually going faster. And here, this turn should have more trees. We can leave it like that because we need to add actual trees, right? So let's do that now. To add the trees, well, we can go to the launcher, go to the marketplace and get some trees. Quixel also give us some trees, so that's what I'm going to get. Here in the marketplace, I'll search for tree. And let's search in the free content. I'll just type tree. And here in price range, there should be a free one. Free. I'm so blind. Here we have Megascans tree, European something. This can also work. I'll just use the Megascans because I have my... I already have this downloaded. So add to project with the 5.0 won't show, so show all the projects, and My project is called My First Racing Game, I believe. Yeah, here it is. Select the 4.27 and add to the project. Let's just wait for the trees to be added. They are a little bit heavy, just in case. I do need to mention that. And just in case you were wondering. So now it has been added. Let's go back to the project. And in the project there should be is this one? Geometry. Nope. Let me search for it. It is this one, black alder geometry, and here we have the trees and trees with simple wind. We could add the ones with simple wind, has a special material that will make the branches move around. If your machine can run it without problems, by all means add them. But in a racing game, it's not usual that people will notice this type of detail, because no one will stay in place watching the trees, because that will mean that you are losing the game. See, this one has this nice movement. Now, taking account the triangles, taking account the number of materials, the number of shaders that are being compiled. Here, if I open one of these ones, should be a little bit lighter, but I will use the ones with the wind, because either way we're going to optimize them a little bit. Oh, and both of them are the same. The thing that changes is the way that the leaves moves. One is through a pivot painter and the other is just simple wind. It was my mistake. So okay, I'll just use the ones with simple wind. Let's just close it. Let's open the foliage again, and we need to deactivate everything here, and I'm going to drag and drop not these ones, not the saplings. I want these first two. One, it needs to wait for the material to load, or well, to the mesh to load, and the mesh loads the material. Then I'll save this. Now I have it here, and this one also. I could add another one actually, maybe this one, the 04, and that should be enough. Okay, nice. I'll drag and drop it again, save it, and we have 3 of them. I'll paint. The paint density should be fine. If I press click, there should be only 1 of them, and it's a little bit small, so I'll just select them and I'll do the same transformation for them, which was 2 and 4, I believe, or 5. Yeah, maybe that's too much. 2 and 3. That's better? Yeah, that's a lot better. And I'll just click. 1 click is more than enough. If I just move it around too much, then you will get a lot of trees very near each other. So just to be sure, let's change the density to 1. And I'll just put them here. And it's better to just point and click, I believe. You don't need to fill the inside part of these parts, because, well, there are already stuff there. There are three trunks. Now you will see my FPS slowly dropping, or maybe fastly dropping. And that's because I'm loading a lot of stuff, right? And most of this stuff I'm not even going to see the detail of it. Especially because I'm moving fast, and also I'm not staying there to search the detail. So I will remove some of that details. Here there should be a whoop. And also here. Yeah, that's fine actually. Now let's go to select. You can see that my frames have dropped to 30 if I press play. I'm losing a lot of frames. Hopefully I'm still recording, but I have a very nice scene. Now, I do not need this amount of quality. I'll go to the trees that I selected, which are this D4, D2, and D1. And as I told you, I don't need that much details. Unreal already gives us a lot of LODs, and well, this package had also more LODs, but this can be reconstructed, right? So LOD 0, I don't see the difference. LOD 1, well, I was already in LOD 0. LOD 1, don't see the difference, but the triangles are less. LOD 2, triangles are less, no difference. LOD 3, a little bit of difference, but a lot less triangles. LOD 4, LOD 5, and LOD 6. That it's just a blob. So I'll just use LOD 4 to force that here in LOD. I could disable it by using custom and just disable it. And here in LOD picker, I can choose also the which one do I want to see, which was the thing that I was doing here. But to make the change happen also in the map, here in LOD settings, I can change the LOD group, maybe to foliage. But instead of doing that, I'll just put minimum LOD instead of 1. This will be 4. So it will always be using LOD 4. And if I go even farther, then it will use the LOD 5. But if I go closer, it's still using LOD 4. You can try with LOD 4, LOD 5 maybe. And yeah, let's try with LOD 5 in everything. Where is it? Minimum 5. This can also be negative values if you want to force your mesh to have super quality even if you are out of the LOD range. So let's just put 5 in everything. And you need to save it. Let's not forget to save it. With that, instead of being at 30 FPS when I press play, we should be regaining some of those FPS. Now we are in 60. And it's running actually kind of fine. Now you can also test which zones are making your FPS drops happen. It can affect, like, oh, this curve has a lot of trees. Maybe I could reduce the number of trees that we are using so our game can run better. Oh, and I already lost. I should lose input of that. And here I wanted to add something very cool at the end. But now we have trees. They're looking fine. And again, with the foliage tool, you can remove stuff that won't make a difference. For example, here, select this one, doesn't really affect the overall look, so I could delete it. And just like that, maybe this one looks a little bit weird, just delete it. Again. And just like that, we can tweak the overall look and feel and, well, performance of our game. So with trees, our track looks a lot better, actually. But we do need to do something about the track itself. It's too clean for this type of environment. In order to have some variations in the asphalt, what we are going to do is go into bridge and search for decals. Here in collections you can find all types decals, and you can find a lot of them. I favorite some ones, well, some of them. Here is painted walk lane. I'll add that one. Here it is. A line, an arrow, again also I'm adding it, asphalt pothole, road dust, road damage, yeah, this can also help, asphalt patch, large asphalt patch, and asphalt patch again. But another type of asphalt patch. So now we have stuff that we can add to our road in the form of decals. This is a starting point, so I'm going to add a line here. I'll go to the decal folder. I'll search for the line. This is the arrow. This is the walk sign. I didn't add the line. White road, and yeah, it seems I didn't add it. Okay, so content drawer, line. Oh, this is the arrow line, road. Here it is. You just need to drag and drop it in your level. Now you do need to scale it so it matches, something like that. Be careful how you scale it, otherwise it won't be believable. Sometimes if you have something like this, it's better to just duplicate it. And we need the arrow. Painted arrow. I'll just put it. Oh no, that's the texture. Oh yeah. Control C. I wanted the material. Again, that arrow is too wide. There it goes. Rotate it. And now we can have multiple arrows. Just like this. And we can test it. Now the things with decals is that it affects everything. Right now you can see the decal affecting my car. To avoid that, we need to go to the meshes that we do not want to affect, like the car. Our car was like sports car. Well, let's search sport car, and there should be a blueprint here. Sports car pawn. This is the one. Again, this is open with Control P. And let's go to the viewport. Let's go to the mesh. And in the mesh, there should be a decal settings to stop it from being affected by decals. So here, search decal. At rendering advanced, receive decals. Let's put it to false. Compile, save it. We can close it now. Play it. And now we should not be affected by our decals. Oh, and it actually could be a better idea, instead of having a countdown, whenever you cross this line, the timer starts actually. Yeah, that actually sounds pretty cool. Yeah, so now let's create some lines. Well, we already have this white line that we can use just to have something in the road that will be flying through whenever we are walking, whenever we are going fast. Oh, and we do need to do the same thing here. We can just have some where's this one, something like this, and I'll just duplicate it. Yeah, something like that, so you know that it's the end or something like that. Yeah, let's add the line here also. White road lined, just like that. Rotate it and put our line like this. Yeah, and be careful with this. Yeah, like that is fine. These lines can also work as these other kind of lines that are usually go in a parallel manner on this type of roads. If I press play from here and I search them, oh, they are too big, I believe. Yeah, but it gives a nice feeling. Yeah, and they're too wide, actually. I'll select with shift. Oh, come on. And I have selected the track. I'm going to deselect it by holding Control and click. And with this, let me just scale it this way. Now that should be a little better. Now I'm not going to do that for all of the track. I believe I have spent a lot of time in that. What I'm going to do here in this part of the asphalt is add some patches like this one. I'll just scale it just so I get a little bit more of variations. We can avoid this again. We need to enter our where's our barrier tool, instance static mesh, decal, receives decal complete, save. Now it's good, and we can add some variations with these types of decal patches. Like, oop, that's the texture. Like this other one, you just need to scale it enough so you just don't even realize that something like this is happening. And again, the player won't even see this, so you don't need to waste too much time by feeling sorry about it, or oh, it looks wrong or something like that. Don't worry, just scale stuff. Oh, and I do need to open this tool again, instance static mesh, and I'm opening it with Control E. Pretty nifty shortcut. Again, search decal, compile, save, and now it does not affect us. Another part of the road where that specific decal could work could be here. And you can rotate stuff around. I'm using the same one in different parts of the track that are not that very near each other, so you don't realize that it's the same one. But I do need to play around with the ones that I added here. I thought I had less, so that's why I was reusing them a lot. Something like this. Here in this part, I want to use the lighter one. I believe it was this one. Nope, that's not this one. Where was it? Road damage, maybe. Yeah, not exactly the one that I wanted to use, but let's just use it either way. We can use this road damage like this. Like something happened there, I don't know. Someone crashed, something like that. Who knows? Who knows? But road dust. Now that this one is pretty good. It's pretty good. Because I can just put it around, move it, rotate it, and it's like another one. Like this part is very, very dirty. As long as the pattern doesn't repeat, then people won't notice, especially if you're going fast. You can go the extra mile and get some little rubble meshes to go there, but you don't really need to. Not really necessary. Here is to clean. Let's add some more decals. Yeah, and you see the point, right? By adding decals whenever you are going through the asphalt, it gives you the impression that it's not that flat. So yeah, it's another type of experience. I for sure there should be a decal. Maybe the last one, the road dust, was actually pretty cool. Something like this. And let me hide this part so you don't know that the pattern is repeating. Perfect. Okay, we have the map decorated. Something that I do want to add, yeah. Something that I did want to add is some objects to be collided with, especially here at the end. So we have a way of not showing that this should be curved. So first I'm going to go back to my favorites. I'm going to add some of these assets here. And these interactable objects will be these trash cans, these cones, traffic cone, perfect, And I had some trash bags, but yeah, once I do it once, yeah, I'll do it once and then you for sure you will get how you can add more of these objects. So yeah, you can also add more things like these trash bags, dirty styrofoam, etc. So let me remove this. And the type of objects that I want to add are just so the game is a little bit more harder and a little bit more fun. For example, we can add these traffic cones. Traffic cone, just drag and drop it to the map. I'll press F so I see that dimension, and it's really small. If I press play, I can almost not see it. So I'll just scale it up to maybe 3. I'll move it around and press end so it snaps. Yeah, 3 is a good size. The other thing was this trash can, and I'll try scale 3. And yeah, it seems like a good size. Is it believable that a trash can will be that size and a cone will be almost the size of my wheel? I believe the cone is alright, the trash can maybe a little bit too much. So let's reduce it to 2. A little bit more believable. Perfect. So I need to add some collision to these assets. So let's just select them, Control E, collision. And this one, box collision, may be not the best thing to do. I'll put, yeah, this one would be better. It's the 18 DOP, simplified collision. Save it. Select the cone. And I'll do the same one, 18 DOP. Or maybe not. 26. That's a lot better, but I don't think it's giving me that much of a convert. Nope. That's 26 DOP could be nice. If you want something more custom, we can remove the collision, go to auto convex collision, and here we can decide the number of hulls that this collision will have. If we apply it for now, you will see that the collision is a lot more exact. And sometimes this is needed. In my case, it's not. 18 DOP or 26 DOP should be fine. Save it. Perfect. Now that these objects have some collision, what we can do is select them. We will go here to collisions. Oh, excuse me, physics, and here simulate physics, and the same one to the cone. Now if we press play and we try to collide with them, then that happens. And it's actually a very fun mechanic. So for example, if at first I have a lot of these trash cans with these cones here, like, oh, you better avoid this, then by going there I'm losing time. So it's actually pretty good. So I'll just put more of them here. Like, oh, you better watch out for this part of the road, man. There it is. And also I want to add this type of collision here at the end. So whenever you finish, then you will for sure have to collide with this. So I'll just put it manually. Oops, that's not the axis that I wanted. Now I could also have created a tool for this, but I'm only going to do it once and that's it. And I should have some cones here. Well, one cone here, and I'll just duplicate it like this. Like, oh, it's the end of the line. Down, come here. And we can select, let's just select through the outliner. Here, just like this. And we can duplicate everything and again, and again, and again, and again. With the bridge also, we can search something, for example, given that we were in the Japanese mood. Let's go to the collections, let's go to environment. Where was it? Tutorial, I believe. Fantasy community? Let me search. Japanese shrine. Here it is. We can add something. Maybe these temple stones. Actually, stones will be very nice for this part. Like this mossy rock. Let's just download it. And okay, these ones. I'll add the mossy rock. And I'll also add these Japanese temple ones. So the mossy rock could go here. And the temple, here it is. One, the scale is super small. Mossy rock, let's just bump the scale maybe to 5 or more. 10, 20. There you go. And the temple 40. Yeah, something like that. 40 may be too much. 30. Something like this. Just so the end is not looking that how to say it, that empty. Yeah, and to not create a collision there, we can just go here, shapes, no, excuse me, volume, collision, blocking volume. And this is a volume that blocks our car. So at the end of the game, we will be here, play from here. Whoops. We will be going supersonic speed ahead. We'll see the line, the finish line, and the blocking volume will stop us from going through the rocks. Nice. Yeah, and that's as much as I'm going to decorate. I mean, you can just copy this. Oh, and they should not be affected by, oops, control, shift, shift, shift. They should not be affected by decals, so search here, decal, receive decals, and now we can duplicate this and move it around someplace else, like, I don't know, here, and rotate them, just to make the game a little bit more difficult. Just don't put them too near each other, otherwise it will be very easily noticeable that it's the same pattern. Hopefully no one realized that in our game. Yeah, and sometimes people just want to crash, so maybe they just do it for fancies. Okay, so that's pretty much it for the decoration part. We just need to start the countdown. Well, I'll get rid of the countdown. Whenever you cross that line, the countdown, the time remaining will start. The checkpoints are working well. Maybe we can add some sounds, which should enhance the experience. I should really fix that collision, but I won't. And I do want to have a end screen whenever you cross the finish line. And if I can add a cool sequencer, then for sure I will want to do that. But at least our map is decorated, and here this should really have a line. I believe I move it for some reason. Better. Save everything. Don't forget that. And let's continue. Now that we are polishing the game, something that we need to address is the sounds. Right now, the game is too quiet, and I believe sounds can really make a lot of difference. So, let's add some. Let's start with the engine. And we're going to use meta sounds, which we do need to activate here in plugins. Search for meta sounds and press yes and restart now. Here my engine has been restarted. So if I search for meta sounds again, we should have it activated. This will let us create a special type of asset. And let's go to my racing game, and I'm going to change the color of this so I can find it very quickly. And inside it, I'm going to create a new folder called audio. Inside audio, there will be sound effects. And here I will create, here in sounds, meta sound source. This will be called sound effects engine, or well, car engine. And we're going to open it. We will be presented with the meta sounds interface, which has this on play node, on finish, and the out audio that we will be able to hear whenever we play this sound. Also, we have some inputs here, outputs. This is the same thing here. We can change the sound volume and pitch, which is something that I'm going to do. But before I change anything here, we need to output a sound. In our case, we will generate the sound inside this meta sound source. I'm going to right click. Here you will find some generators, and we will use the saw one. Okay, let's use this one and connect it to the out mono. Now we want this to keep looping, so I'm not going to use the onFinish input or, well, output or the onPlay input. Right now, if I press play, the volume will be too much. So here in the source, I'm going to change the value of my volume to 0.3. Now if I press play or press spacebar, I will see the sound that is being generated by this. I'm going to change this frequency, and I'm going to here drag and drop and promote it to a graph input. What this allows us is that whenever we press play, here we can change the value of this specific input. and I'm going to just lower a little bit the sound on my recording. Perfect. So with this, we can play around on how do we want the engine to sound. I already know which values I'm going to use, and by default this one will be 70. Now it's sounding like that, but also I'm going to change the pitch of this meta sound. So I'm clicking here in source, and in pitch I'm going to change it to 0.5. Right, so now it should be sounding something like this. Okay, and that's it for this meta sounds car engine. Let's use it. I'm going to open with Ctrl P, blueprint. Well, it's called Sport Car Pound. Here it is. And I'm going to add a new component here for the audio, because right now I have my meta sound asset selected. Here it auto-completes audio and immediately puts the sound effects. I'm going to make sure that this is being auto-activated, and I'll compile and save everything. If we press play, we should be hearing the sound that we created. But we do want to modify that sound whenever we are accelerating, right? And so this frequency needs to change while I'm using my car. And that's the thing that we are going to add now. Let's first add the code in the car. And I'm going to go again here in the tick. And because this is gameplay stuff, what I'm going to do, I'm just going to move it a little bit down, and here, sequence. And now I'm going to here add code for all the things that will be using the sounds. So for now, I'll get this component, and I want to change this input frequency. So I'm going to set float parameter, and the first one is fine. Just like that. Here we can add another float, and for example, if we put here 400, now the value should change, but it didn't change because I didn't input the correct name. So frequency, and now the value changed. Now what value do I want to use? I'm going to get the same chaos wheel vehicle component, so I'm going to copy and paste it. It's weird because if you just drag and drop this one, it's not the same one, but you can right click and type chaos vehicle, and it should be, oh, excuse me, chaos wheel, and here it is. You can get it like that. And with this component, I'm going to get the engine rotation speed, which is the RPMs of our car. Just so we know which RPMs we have, I'll just put this one at 0, and I'm going to print. In our example, right now we have 900 as a base value, and whenever we are accelerating, we are reaching like 500 something. So maybe I'll use as a start value 900, and the max, can I get the max? Engine max rotation speed. Yeah, we can get it like this. why do I need the base value and the max value? Because this parameter will be these frequencies here, like, and the values that worked for me was 700 as a base value, and another one as a maximum value. So we won't hear the same sound over and over again, and I'm just putting those values as the ones that I got through testing. Okay, so how do we convert this rotation speed into a frequency that we want to use? It's easy. We will use a map range clamp, connect the float, and we need the in values, which, if you remember correctly, the base value of the RPMs was 900, and the maximum value of the rotation speed was, well, this one. And we can just connect it like this, so we know which one is the maximum value. There it is. And now, here, in the out range, these are the input values, the ranges of the input. Here I want for the base value to be 700 and, 70. And this one, 150. That way, whenever we press play, if we accelerate, the frequency should be able to change. And every time let me connect it again, engine rotation speed, every time this value changes, our frequency will change with it. So it's pretty cool. Right, that's actually very, very cool. But we do need to do something about the fact that if we go backwards, I'm getting like the sound like if I was accelerating forward. So we do need to change that. So the way we're going to handle that is through looking what value does our brake has. Now we have two types of brake. Where is my inputs? Here. If I move forward but in a negative axis, like pressing in my keyboard S, this will set the brake input. And the other one is if I use the handbrake, which sets the handbrake input. I'm going to use this brake input. So here, before we do any of this, I'm going to get the brake input with this component. And it's not brake, it's this type of brake. Get brake input. And I need to connect this here. Right. The brake input by default just gives me 0 and 1. And this is happening because I'm not using a joystick or any kind of other input. I'm just using keys, so I only know if it is fully pressed or not. Right, so with this, what I want to do is change the pitch multiplier of this engine. So I'm going to drag this again, set pitch multiplier, and let's connect this here. The way I want to change this is that when this is 0, I want to leave it at 1. So again, I'm going to use a map range. And it's clamped because I do not want it to escape from the out range values. If it was unclamped, this maybe escapes by 2 times the out range, then this also would change. So here I only have 0 and 1. When it's 0, I want it to be 1. And when it's 1, we are breaking, I want it to be 0.4, so it gets a little bit lower. And yeah, we'll see what's happening now. Let's press play. I go backwards and it gets lower. I go forwards. It's normal. I press S and it is changing, but it's changing too much for my taste. So I want this change to be interpolated. So it's a lot smoother. So let's just float interp to. The current value will be, well, this SFX component holds the value of the pitch multiplier. So get pitch multiplier, and this one is the current value. Nice. Now, the target value is this map range. The delta time is, well, these delta seconds. So let's just grab it from here. And the interpolation speed, I will put 1, so it's a little bit slow. Now with this, yeah, let's arrange it like that. With that, we can press play. Now, worked correctly. When I go backwards, yeah, it's a lot smoother. The sound is a lot smoother. And let me bump it up a little bit so it's easier to be heard. Perfect. Now this adds the extra functionality that when I'm braking, the revs, the sound of the engine also changes, which is very nice. And I'm going to get rid of those values. I'm going to put this here. And what else do I need to add in terms of sound? Let me just put this here so it's not looking that badly. I'm using reroute nodes again by double clicking on top of the wires. Okay, so a sound that also we need to add is the braking sound when we are using the handbrake, because that's not affecting our engine sound and it should be a little bit different. So let me save everything. And I can close this. I'll save it and I'll close that. Let's add now a sound for when you handbrake and the car skids around. For that, I tried to create one in Metasounds, but I end up downloading one from here. It's called Brake. Freesound is a web page, freesound.org, where you can create a free account and start downloading, well, free sounds. You need to take in account the licenses, but most of the time they are very open. So yeah, you just download it and you will get this file. And I just rename it to break.wab. Well, the format was already like that. And you can play it to see how it sounds. Yeah, and that's pretty much it. I need to import it now to my game. So I can put it right here next to the meta sounds, and depending on how much sounds you're going to add, it would be wise to create a folder. In my case, I only have these two sounds. Maybe I'll create 4 more. But now I have it, and I'm going to call this because it's a sound wave, right? If I double click it, pink audio, it's a sound wave. I'll just call it sound wave break. And I can hear it in engine, but I also want to create another metasound asset. Metasound source again, and I'll call it SFX brake, and car brake would be better. I'll open it, and well, save everything. Now this metasound asset is different from the other one because we are not generating the sound, we are playing one. So we need a wave player. And here it is. We need a wave asset, which is the sound wave break. And we need to determine the output, the out audio, and the output on finish and on play. So whenever I press play, which should be like this, I want to play this wave player. And whenever it finishes, I want to finish the sound. If I press play, nothing is happening because I have not connected this audio output. Now, because this is a wave player, we have a left and right output. This is a stereo type of output, but right now we are outputting mono. You can change the way we are outputting things. Here, output format, stereo. Maybe in the future we will get 7.1, but for now we only have this. Why am I using mono? Because the audio, I really don't need to hear it in the left or the right because the engine will be in charge of spatializing that sound, in charge of the spatialization of where should the sound play, and then I could hear it from my left side or my right side. So I'll just merge these two. You can just add it like this. Or if you want to have more control on the volumes, you can just mix them. Mono mixer 2. And you can change the gain levels here. Okay, so now if I press play, I should be able to hear the wave player. Now, whenever I break, this will be playing endlessly. So I would need to loop it. And here we have the loop checkbox. And now we have that sound. Now I don't want to hear the same sound every time I break. So we will create little pitch variation. And for that, well, we can change this pitch shift, for example, -14. And whenever you're pitching it down, you will see that the audio is a little bit slower. And if you pitch it up, it will be faster. Just take that in consideration. So what I want to do is generate a random number here every time we play it. So here I'll just press random, and if you just type random here, you will need to choose which type do you need. So it may be better if we just drag from the pitch shift, which is a float now, and let's just type random. Now we need to generate this, so whenever we press play, this will be next, and whenever this gets generated, we can finally play. Now the minimum value, I already tested some of these values, and -14 and -18. And let's play. Let's play again. And the pitch varies. And you can play with the numbers, with the frequency numbers. Those I liked these ones. And also you can expose them like we did before here. And then we can change it in the blueprint, but I'll just leave it like this. I'll save this, go to my sports car pawn, and now I need to know when to play these files. Now here I'm in the tick, and in the same tick, after the thing we did here with the frequency of the car engine, what I will do is change, or well, check if our tires can play the sound, and I want to play that sound specifically when they are sleeping. And by sleeping, I don't mean like snoozing. Let's just do it. Copy this, and we can get the state of the tires. So get wheel state. Here we have an index. We can use this index to select the wheel that we want to create. The front ones are 0 and 1, and the ones that I want, which are the back ones, are 1, and I'll duplicate this, and 2. Now I have a lot of information that I can get with these wheels. So I'll just break this structure, and I'll do the same here. Like so. And here I know if my wheels are sleeping or are skidding. The one that worked very well for me is sleeping, so I'm going to use that. And again, you can deep dive in what everything here means if you watch the Unreal video that I showcased at the start. They talk a lot about the things that you can do, and it's a small video, so there is also a lot of information that you can use. So whenever any one of these wheels is sleeping, I'll just use an OR boolean, so it doesn't matter if this is true or this is false. One of them must be true and this will be true. So if one of them, any of them, fulfills the true value, then what I'm going to do is play this sound. Because this sound will be played also very frequently, and I have it selected here, I'll select my car brake. I'm also going to add an audio component. So let's select the blueprint itself and add an audio, and should be auto-completed because I have the asset selected. So now with this, I can play the sound. Right, before doing that, let's remember that by default this is auto-activated. Here it is, auto-activate. So it means that if I press play, I will be hearing the sound every time. So let's deactivate that, put the auto-activating false, and now here I'll just play. And if I choose this one, it's going to create the same variable, but it's okay. And whenever none of these are sleeping, then I'll just here stop it. Now I don't want to to break your ears or your listening or do some harm to your ears. So instead of just testing it, I can tell you right now that there's a little bit of a problem here, because once any one of these tires enters this state, it will keep trying to play the audio. So we only need to do it once, because here in the meta sound, whenever we play it once, we are already looping it. So here I'll just add a do once. And whenever it's false, then I want to reset this. So I'll just create a little sequence. And I'll reset this here, and then I'll stop my logic. Now whenever our tires starts sleeping, well, we will play the sound and we can see how that sounds. I'll use the handbrake. Oh, nothing's happening. Perfect. Should be. Ah, there it is. Whenever I go into greater velocities, then it's a lot easier for the car to start sleeping around. Also works when you just brake if you're going fast on your brake. Yeah. So now we have the sound of the brake working like that. And yeah, that's pretty much the implementation that I wanted to do here. Oh, and I made a little mistake here. 0 and 1, like I told you, was the wheels on the front. I needed to use 2 and 3. So this one should be 3. And that could be why it was not playing sometimes when I was braking. Yeah, now. Yeah, now it's working correctly. Ah, that was it. Yeah, it was weird because I already tested this and it was working correctly for me. Excellent. Given that we are already in the car blueprint, it would be a good idea to add some crash sounds. I also got this crash sound from Free Sounds, the Dork. This is the name, I can play it. And that's the sound that I will be using. I already downloaded it and rename it like this. So I need to import it. Again, I'll just drag and drop. It's asking me if I want to use the sound wave already there as a template for the sounds being imported, and I'll just press no. Now we have the crash. This one will be also SW crash. I also need to create a meta sound source, and this one will be car crash. And we're doing something very similar to the last one. So again, I can just copy and paste this. It's the same thing. Here, play, finished, like this, and now we do need to change this wave asset. Let's use the crash and let's save everything. Right. But I do not want this to loop. I do want it for the pitch to be random, and the values that I'll be using is -8 and 4. And not -4, just 4. Now if I press play, it will always be a different kind of crash sound. Yeah, and that's all the setup that I need to do here. Let's save this. And let's go back to the sports car pawn. Now here is the tricky part, because I'm not going to use the tick for that. I don't want to check every tick if my car is colliding with something. So here in the viewport, I can select the mesh of the car. With the mesh of the car, I can add an event, and we will use the hit event on component hit, because a hit is a collision between two blocking actors or meshes or components. So whenever you cannot overlap one of the components or actors that are colliding, then you will get a hit. So here, just to test this, we can play and no hit. Why is this happening? Because we need for the mesh itself and the collision itself to give me those hits. So here, in the collisions, where are those collisions? I need to have this checked. Simulation generates hit events. This should work, but for some reason it doesn't. The way I made it work was that I needed to open the skeletal mesh of the car, go to the physics asset, select this collision, which is the actual collision of the car, the body, and here I'll add the simulation generates hit events. With that added, and let me save it, I'll press Alt P, so I'm playing the game immediately. I touch the walls and it prints hello. Now the thing is that a hit event is very sensitive. If I just touch one of these, I'll just touch one of the cones. As long as I'm hitting it, it's triggering. So I need to find a way of not triggering too many times that hit event. And I'm going to close this part, also this one. Why? Because if I'm triggering this print string many times, it would mean that if I had here a play sound node, it will reproduce and it will play hundreds of times. So that's not a thing that I would want to do. So what we'll do here is just play a sound at location and select our car crash, and the location will be the actor location, which is the car location. And please do not press play yet, otherwise this sound will be played a lot of times, like you saw this print string. Right, so now, oh, and I'll just leave the print string. What I will do is create a little array here in variables, and I will call it collided actors, change it to actor object reference, and here in the details panel change it to an array. So now we can have a list of the actors that I have already collided. So whenever I collide with something, I want to add them to my list. So let's say we print the string, we play the sound, and then we add the actor that we collided with. And let's just add it to my array. And it's this other actor that I want to add to this array. Perfect. Now, before adding something to this array, I want to know if it's already in the array. So what I will do is I'm gonna get the collided actors array again. I'm gonna try to find the item like this. And if I don't find it, like it says here, it will return -1. So I just need to validate if this is less than 0, it means that it's -1. If it is less than 0, then for sure it's not inside the array. So let's just run the code that I have here. By doing this, if I press play and I touch this one, the sound triggers, but if I collide it again, it doesn't, because it's already in the array. So I'll just solve this very naively by just creating a timer, and every, I don't know, 1 second that we haven't hit anything, we will reset this collided actor. So I'll just create here custom event called clear collided actors. Oops. And the code is very simple, just call clear. That's it. But I do need to call this after 1 second that this has been triggered. So here, I'll just, at the end, I'll create a timer. Set timer by event. This time will be 1 second. It won't loop. And the event that I want to connect, or that I want to trigger after 1 second, is this one. Now you can do it like this, but if you don't like that a wire is hanging like that and it gets on your nerve, you can also create event, and here you can select the event that matches with a function that can support a timer, which is any type of function or event that doesn't have inputs parameters. So here it is, clear collided actors. Now, the thing is that whenever this gets called again, if there was already a timer here, then that timer will be resetted because I'm connecting a timer to the same event. So I won't worry too much about it. I mean, we could create a variable here and control it a little bit better, but for now, this is enough. Okay, so what I will do here is just test it, because that's pretty much it. Let's collide with this. A second will pass, and I can collide again. If I remain touching this wall and I'm pressing forward, then the hit will keep triggering. If I'm not pressing forward, then nothing happens. So now we have the crash sounds. And it's feeling a lot better. What I want to add here is whenever we crash, have some camera shake also, so let's do that now. I have already covered how to add camera shakes, so at least that part will be very fast. So let's just create the camera shakes. Here, camera shakes, I'll just call a new blueprint class, all classes, camera shake base, not the source actor, this one, camera shake base. And I will create the camera shake for a hit from the bottom and a hit from the sides. So let's create the bottom one first. This is camera shake, and I'll select everything with Control A. Again, camera shake, car, or bottom vehicle, bottom crush. And I'm calling it like this so it makes sense in terms of naming. So inside it, again, I'll just add a Berlin noise camera shake pattern. And here, I'll leave this to 1, X will be 0, Y will be 0, and Z will be 5000. The frequency, I can leave it like that, the duration 0.4, and the blend time, the in blend time will be 0, so it's like very, not very, but it will be a lot more violent than if I just blend it in. Okay, so this is for the bottom crash vehicle. This is the camera shake asset that I will use. And I will duplicate it. Call it camera shake sides or side crash vehicle. And maybe it would be better if I just put crash before button. Crash button. And here, whoops, crash. Why would it be better? Because I can find the crashes very easily because they are next each other. So now let's open the side one. And in the case of the side, the X should be in 0, X is forward and backwards, Y should be 5000, and Z will be 0. Z could be, let's just add a little bit of this. Yeah, something like that. And this other value, this is fine, 0.4. This is fine. Compile and save. We can close it, and now let's use it. To use it, we already have this on component hit mesh, and we need to not only play a sound, but also play the camera shake. And for that, I'm going to make my notes, my other nodes be a little bit. So we already have a camera shake source here, so let's use it. And this camera shake source will be start, and it will not only be a start, it will be start camera shake. That is so we can set up the class, and I'm going to press Ctrl and drag to reorganize my wires. The camera shake class will be crash bottom or crash side. Now, we need to decide which one of these do we want to play. The way we're going to do that is with this information that the hit gives us, which is the normal impulse. If we just connect the normal input here to my print string to see what that looks like, whenever I'm crashing, I will see that we have values in X and values in Y, and not any value in 0. Z, I will only get values there if the crash happens at the bottom, like that, where my car gets a little bit of fun, and then when I collide, then only the C value had something to say about it. right? So with that, what I'm going to compare by using a dot product is I'm going to compare this normal impulse with the z-axis, like this. This value, just to give it a little bit of explanation, like it says, returns a dot product. The dot product is the relationship between the direction of two vectors. So if the vector is, I'm comparing this vector and this vector, if this is completely perpendicular, this will be 0. If both vectors, and remember I'm using the c vector, and let's say my normal impulse is like this, then they are kind of going in the same direction, so it will be a value between 1 and 0. If this other vector was going downwards, but it's exactly parallel, it will be -1 exactly. If it's completely parallel, like this, then this will return a 1 value. And well, we're going to use that to know if the vector is going upwards or not. I'm going to use 0.5. So I'm going to detect every vector that is going this way. Something like this. This could be the midpoint, so I'm going to detect from here to here, and I will do the same for the other side, like this. And these values should be between 0.5 and 1, and the other ones, let me just delete that, the ones here should be from -0.5 and -1. So to get rid of any symbol, I'll just create this node, which will give me the absolute value. So if it is negative, it becomes positive, and if it is positive, it remains the same. And now I'm going to ask if it's greater than 0.5. If it is, then I want to play, and I need to put this near my camera shake. Okay, so if this is true, then I want to play the crash from the bottom because it's going in the direction of the z-axis. So I'm going to here, type select, and connect this Boolean value to the wildcard. So if it is true, I want to play the bottom vehicle crash, and if it is false, then the crash side vehicle. Just like that, and I'm going to arrange this, like this is fine. Now if we crash from the sides, our camera should only move side to side, and if we crash from the bottom, then our camera won't move side to side, but only, and I need to pick up a little bit of speed, like that one. You see that whenever we crash from the bottom, or well, near with the actual racetrack, then the camera was going upwards, and whenever we're crashing with the sides, it only goes to the side. Now it is random, so if you want to create like, a crash from the left side and a crash from the right side, you could do that. And you would use a logic very similar to this one. And let's just remove this, and I'll also remove the print string. And I can put the collided actors here. You will use a logic similar to this one, but instead of comparing the C value, you could compare the X1 if you want front and back, and the Y value, something like this, like 0, like that, if you want left and right. There it is. So with this, we have added the sound and the camera shake when my car crashes. The last sound that I want to add is whenever you cross a checkpoint. We have already polished our car enough, so let's just maybe add some comments. Crash, SFX, and camera shakes. Oh, and also I need to fix a little something, because right now if I press play, this start camera shake is set in the class to either one of these. And whenever, where is our, here is our tick. Where is our camera shake? This one. Instead of just choosing start here in, remember, tick, and we're changing the field of view and we are adding some camera shake here, what I'm going to do here is stop, excuse me, start camera shake. I'll delete this and I will assign the correct one here, the fast vehicle camera shake. Otherwise, whenever this would be triggered, we will be playing the camera shake that should happen only when you crash. Okay, so now that should be out of the way. Let's save. And we can close, yeah, let's close this sports car pound. Let's create the sound effects for the checkpoint. And for this one, we will only be using meta sound generators. So sound effects, checkpoint, crossed. Let's open it and we are going to again generate, use those generators. This one is the triangle generator. And let's save everything. I'll save all. I'll connect the audio to out mono, and if I press play, it will give me that sound. We can change the frequency, and that way we can create new sounds. Now I noticed maybe that my engine was a little bit louder, but for now I will leave it like that. We can modify the volumes later. So here on play, I don't want to loop this sound. Like, for example, right now our unfinished is on the open, so if I just press play, the sound will remain playing over and over and again. For this part, we need to create a little bit of a delay. Trigger delay. So if it is 1, for example, and let me put a nicer sound, maybe not one so aggressive. We just delay this unfinished by 1 second. 1 second passes and it ends. So what I'm going to do here is create, it will be a simple sound. First, this frequency, I will turn it into a variable. Not a graph input, a graph variable. And that's all I have to do for this part. Now, whenever we have this trigger delay, we want to set up a new float value for this frequency. So here, I'll just set value, no, value, here it is, value float. The initial value of my frequency, I will be using 1800, and the target value will be 1200. The output value will be this frequency, so I can drag and drop it. And here it says set by shift drop. So let's hold shift, and there it is. Output value connected like this. And now I want to play a sound again, or well, now that the frequency is changed, I want to wait a little bit so a sound can be heard. So I'm going to copy and paste this trigger delay and on set, in and out here. Something like this. And the timing of the notes, I want it to be very fast, like 0.1 and 0.1. With this, we can press play, and that will be my sound whenever I cross a checkpoint. You can change these values if you want to change the notes that you will be using. But for me, this is more than enough. Also, you can use the same approach that we did for the other ones, like this one, where you have a sound already downloaded that you can plug in, and that's it. Okay, so let's use this checkpoint, cross sound, blueprint, checkpoint. Oh, and it got hanged there. I'll just pause and I'll talk to you in a minute. Okay, it didn't crash, so we're good. Here in the blueprint checkpoint, what I'm going to add on component begin overlap, it's just play a sound 2D. A two-dimensional sound is a sound that you will always be able to hear. And this is the case because I really don't want to hear this sound on the space of the game. I always want to hear it. I really don't want to hear it louder if I'm closer, or quieter if I'm farther. So this is very useful for UI sounds, and in my case, sounds that are very important for gameplay. So let's use checkpoint crossed, and now compile and save, and every time I'll pass a checkpoint, we should be able to hear the sound. First checkpoint, there it is. So it does work. Compile and save. Perfect. Now, another thing that I notice, and that we need to also fix or polish, is the fact that if I have a checkpoint here, and I'll disable the sound of the engine. Whoops, I closed the checkpoint. Let me just disable the sound of the engine so my voice is clearer. Otherwise, I would need to edit a lot of stuff. Car engine, let me put it at volume 0 for now. Perfect. So I'll just drag and drop a checkpoint here. One exploit that I found was that if I cross a checkpoint and I cross it again, I get the value. So this should be only a one-time use. And just in case, I'll create a variable. Integer, it could be a number of uses. This will be instance editable. Maybe if I need it, I really don't know if I do need it. And whenever we want to trigger this part, I will first ask if my current number of uses, which I have not created yet, if my, I'll just type number. If my current number of uses is greater or equal to the number of uses left, then I should not be able to use the checkpoint. So I will use the current number of uses is less than the number of uses, and then this kind of logic should work. As soon as this passes, I do need to add 1 to the number of uses, and I will use this node called increment int, which is ++. So now, if by default the number of uses is 1, and I do need to put 1 here, and the current number of uses starts at 0, then whenever I cross a checkpoint, and I want to cross it again, it won't trigger. So that's pretty cool. And with that, we get rid of the problem of overusing our checkpoints. Perfect. Now we are in the final stretch. We just need to validate whenever the game starts. I want to change the way the logic works, and let me save everything and close the classes that I don't need. I also do not need the bridge anymore. Let me save everything. And for starters, I want this countdown to not happen. I want to cross this line, and then I want the game to start. So for that, I'll go to the game mode. And how did I call my game mode? It was GM something, right? Yes, racing game. And here, let's go to the event graph and start countdown. Instead of just starting countdown, I'll just go to an idle state, like preparing phase or something like that. Just so I don't need to delete this, because maybe I will use it in the future, I really don't know. I'll just create a custom event and call it pre-race. And I'll just put a print string in pre-race state. Instead of starting countdown, I'll just enter the pre-race state. And to start the game, there's already a game start. So here in the map, I'll just create a trigger volume here. Where are my volumes? Where is my not blocking volume? Trigger volume, here it is. And I'll just put it in the ground with, well, let me just scale it first. Like that. Press the end key and put it in the ground. Move it here. And scale it to the side, so for sure it will be considered. Great. Now I will go to the, where is my level blueprint? And we haven't talked about the level blueprint. By default, oh, it seems that there was already code in this vehicle example map. But a level blueprint is a blueprint exclusively to the level. And it doesn't have a viewport or a construction script, because we will have access to every actor that exists inside the level. For example, we just need to select it. I'll just select my trigger volume, And now in my level blueprint, I can right click, I can create a reference to the trigger volume, or better yet, I can add an event for the collision begin overlap. And what this will do is get the game mode. I do need to cast it to my game mode. And then just call race start. Or game start, I believe it was. Yeah, game start. Compile, save, press play. And now we start the game as soon as we cross that line. A thing to have in consideration is that if you create another map, the maps does not share the level blueprint, so this will be completely empty. If you're facing this type of issue where you're having to add this code every time you create a map, which is the thing that will be able to happen, or it's most likely that it's going to happen, it would be better to create a blueprint that had this trigger, and that blueprint always called the game mode and always starts the race. I'm doing it like this because I also wanted to show the level blueprint that you can use inside Unreal Engine 5. And well, 4 for that matter. Great. We have changed the way that our game starts, but now we should change the way that our game finishes. First, let's close the level blueprint. I know this is the level blueprint because it says so here. And in the game mode, we have a way to know when the game finishes, either by losing or by winning. In my case, it doesn't matter what happens. What I want to do is remove the input. To do that, we can call disable input. If I'm not seeing it, it's because I need something to disable, and the game mode is not something that can be disabled because it doesn't receive input. So let's get first the pawn, and with this pawn, disable input. It is asking me for a player controller, so let's get player controller. Let's compile and save, and I can right click and play from here. And the thing about this is that whenever I disable the inputs that are currently in use will get stuck there. For example, if I'm accelerating, my input has been disabled and I cannot stop accelerating. And also, play from here again, if I was turning, then doesn't matter what I do now, it's still turning and going forward. So the inputs are disabled, but not exactly the ones that I needed. Also, if you had more inputs in your player controller, that is not our case is inside the player pawn, you should also do something like this. So stuff here inside the player controller are also disabled. Right, so let's fix this. In this case, what I'm going to do is, well, let's just cast it to my chaos. Oh, let's just cast it to the sports car then. Yeah, otherwise cast to vehicle, will vehicle pawn. What I want to change is the steering value. Set, or well, the throttle. Set throttle input. If I can do the same thing with this, it would be better. Seems like it's okay. Set throttle input to 0. Just like that. And you will see that in our sports car. Those are being set up here. Move forward, set throttle input. and that. So with that, I believe that we should stop. Let's just play from here. And I'll keep going forward. Yeah, the throttle input has been changed to 0, so everything's good. Now, one thing that I could also change is to start braking, which, yeah, should be a nice addition. Let's start braking. Set braking input to 1. And also set steering input to 1 also. That way, look what's going to happen now. If I play from here and I get some speed, as soon as I cross the finish line, my car will start steering to one of the sides. Oh, I did not anticipate that the brake will make me go backwards. So instead of set brake input, set handbrake input to true. Maybe this could give us a nice drift. And let's say I'm playing from here and I'm going super fast, and that's the end. Ah, that looks very cool. So nice. So nice. Okay, so we have removed the input. We have added that cool addition. What we could do also is have a new camera that can, and maybe even play a little animation in sequencer. For that, let's create a sequence. Here in my racing game, I'll create a new folder and cinematics. Inside it, new folder. Let's just call it end sequence. And yeah, I'll create the sequencer asset, and I need to do it here. Add level sequence. Select my racing game, cinematics, end sequence, and this one will be called win sequence. Save. And now I need to add a camera here, create a new camera and set it as the current camera cut. This is not a sequencer tutorial, so I'll just show you around how to do some stuff, but not necessarily explain everything about sequencer. So by clicking that, now we have a camera that is looking here. And a cool shot could be something like this. We start here with the transform. Let's create a new key. And let's move it around here. And I don't want to collide with that. Maybe like this. And I messed up because I needed to move this before moving my camera. So what I'm going to do here is this. Something like that. Okay, so let's create a key, new key, and you can also press enter, and we can see how it's looking. If I press play here. Yeah, it may be a little too fast, so I'm going to move it at the end of this sequence. And it should be a little bit slower. Now, I really don't know how fast or how slow my car will be going, but at least I have a sequence that I can use. So let's just save it and let's go out of this sequencer. We can close it and we are out of it. And we have the level sequence here added, the win sequence. What I want to do here is that whenever we win the game, and where is the game finish, cross the finish line, here in game finish we could create the cinematic. For example, here, this is all the code that we done for the input. We can create a little sequence here, and here we will be playing a level sequence. Now the way that this works is, first, it needs to be in the level. Second, just to have a little identifier, what I'm going to do here is add a little tag to it. And where is my tags? Autoplay needs to be false, so it doesn't autoplay. Here I'll search tag. In tags, I'll add the text win. And now what I'm going to do here in my racing game, because this tutorial has been going long enough, I could trigger it in the level blueprint, or here in the game mode, I can search for the sequence like this. Find all actors. Find actors of class, excuse me, or get all actors of class, excuse me. The class is level sequence. Level sequence actor. This is the one. Now I need to search for every sequence, level sequence that is in the level, and I need to check, like get tag. I want to search if we have the winning tag here. Now I'll press find item, and to know which tag do we want, I need to first, well, know if we are winning or not. So I need to do something like this, and I'm just going to select here and connect my winning input, just like that. If it's true, if we won, here I'll create a literal text, well, name, and call it win, which is the same tag that I assigned to this one. So if we find that tag inside my actor, then for sure this will be 0 or more. So if it's greater or equal than 0, then we're fine. So if we find it, I want to play it. Play. Just like this. I'll do something like this so it doesn't get too confusing. There it is. Okay, so now this is searching all the actors of the type of level sequencer. This is searching, well, getting all the actors and individually checking if one of them has this tag, and if one of them has it, then we play it. Again, we're assuming that only one of these sequences will have a win tag. So let's just save everything, compile, and let's press play from here. I'm assuming this is correct. If it isn't, then we can debug it a little bit. Yeah, and it's too slow. And I don't know what I was thinking. So I'll just click on the sequence, and in order to open the sequencer again, we can just click here, win sequence, and we have it now. I'll just put this at 100 frames, test it again, and I can close the sequencer again. It may be too slow still, but then I will do a little change so it's a little bit faster. Yeah, it's too slow. So I can click on my level sequence, and here I'll remove this tag search. In the play rate, I'll put 3 times the speed, and now should be more than fast enough. Play from here, and now oh, that's pretty cool. That's actually pretty cool. Now, when it finished, it gave me back the control, so I'll just put here pause at the end. And now we have a way to end the game in style, right? So let's check it out. Oh, so cool. So cool. Perfect. The last thing that I want to do for our game is that whenever we lose or whenever we win, I want to stop the engine sound, because I just reactivate it here, and if I press play and our time ends, then our engine will keep playing. Yeah, and that's not right. So let's just go to the game mode again. Here we were setting the throttle, the handbrake, and now I will need to get again the player bound, cast it to my sports car, get the audio component, which was engine, this one, and press stop. Well, call stop. That way, whenever we finish the game, and again I lost the finish line. Where is it? Here it is. Play from here, cross the finish line, and the sound stops. Now we could add a little interface to say, oh, you won, click here, restart. You lost, click here, restart. And I mean, the story is long enough though. How many hours is it? Oh, 5 hours. Yeah, let's do it. It's simple. Let's do it. Okay, so let's create the interface for the lost and the interface for when you win, right? And let me save everything. Will be very fast. Again, like sequencer, I'm not going to explain everything that you can do in UMG, which is the way that we can create interfaces like this, user interface widget. Let me create our folder called interface UI. This one will be called user interface widget blueprint user widget. Let's call it widget blueprint win screen. This win screen, we need to position stuff on it, so let's use panels. Panels allow us to organize stuff on the screen. I'm going to use a canvas panel here. In my canvas panel, I'll put a text. Where's my text? Like this. This text will say, "You win." I'm going to center it, or I can press size to content also. It's fine. Now, this UMG editor lets us be able to know what would happen if our screen is resized, which can happen, and if you are developing something from mobiles, it will happen. So it's important to anchor it to some place that will make sense. For example, if this was at this side, if we resize it, we will lose it. But if we anchor it to the right side here, then it will adapt because it will try to maintain this distance. Having said that, this one, I'll anchor it in the middle, position 0, 0 again. The alignment will be 0.5, and I didn't put 0.5, 0.5, and let's increase the text size. You win. I want a button here, so I'll just drag and drop a button. This button, I will anchor it to the lower side of this. The alignment will be again 0.5, X will be 0, and I'm going to put a text inside it. Then I'll make the button a lot bigger, like this. Again, reset the position. Text block will be restart game. With this, maybe the text should be a little bit bigger, maybe 35. There you go. You win, restart game. We want to click this button and do something. To do that, well, let's just click on it. And here in the details panel, just like in blueprints, when we're working with components, these are not components, these are widgets that we can put inside other widgets, but they also have events. This one is on clicked, is when you click and release, and you're inside the button. On press is immediately after you press, and release is, well, when you release. So I'll just unclick, and what this will do is open this level again. So open level. If you use by name, we need to know the name of the level, which is vehicle example map, but we can also open level by object reference and select our vehicle example map. Compile and save it. Now we need to create it. So now here in the game mode, racing game, and I'm going to do it very fast. Whenever we win, which is here, win, cross the finish line, before the game finishes, I'll just add that to my UI. So I'll just, well, to my viewport, I'll create the widget. If this would be a bigger project, I would do everything that I'm doing with widgets in the player, in the HUD class. But for now, I'm going to just create it like this, create a widget, add it to the viewport, and let's be done with it. Now when we win the game, let's go back, let's go here, play from here, play, you win. Now it's missing some of the flair, so I'm going to add a little animation. I'm going to select the canvas panel. Gonna go to animations here, going to add an animation called fade in. I'm going to select the animation, this will get activated, I can create a track, I'm going to select the canvas panel because it's already selected. Now here, create a track, render opacity, at first it will be 0, whenever, oops, I didn't mean to change the green bar, and at 1, this one will be 1. And if we press play, we have the animation, and it's working correctly. Now we need to play it whenever this gets created, so here in the graph, like we had events, we can have more stuff to drive data and, well, in my case, animations. So in the event construct, which is very similar to the begin play, I'm going to drag and drop this fade in and play the animation. Play the animation, playback speed if we want it a little bit more fast. Play mode forward, we don't need a fade out if we use the reverse mode, but let's just use it like this. Now let's try it. Play from here. And now we have it like this. Now I can't click the button unless I press Shift F1 and click on restart game, which will open the game, well, the level again, which means that our game is restarted, right? Because I'm restarted all the level. For my mouse to appear again, we need to get the player controller and here show mouse, set show mouse cursor and put it true and connect it like this before the game finishes. Now let's press play. Oh, too far. Play from here. And now I have my mouse. Let's restart the game. And I still have my mouse. So I need to do something here. Okay, so whenever I finish the game by winning, I want this to not only show the mouse cursor, but also set the game input mode to game and UI. The UI I want to focus is, well, inside this widget that I just created, and it's called the button. I want to focus this. That way, if I press enter, I may be able to use it. Oh, come on. Right. And whenever this game starts again, which is here in the pre-race, I want to do the opposite, like not show the mouse cursor and also don't need the input mode in UI, set input mode game. And I will put this in my pre-race phase. With this, compile, save it. Let's press play from here. You cross the line, you can click the button immediately, you don't need to select, like, give it focus and then start the game. You can even press enter and it will work. And now my game starts working normal. This is all well and good, but I have not addressed the fact, and let me save everything again. Save all. I have not addressed the fact that there also needs to be a losing screen. So let's create a sequence for the lose screen. And yeah, let's start with that. For the lose sequence, which I need to create again, add level sequence, here, lose sequence. Let's just create something very simple. I'll just create a camera. And I'll just go through the map, like through parts of the map, like from here. I'll start with the transform, whoop, move it here like 100. And if you want to move your camera freely, you can just click here and it will automatically add a key when another key is already added. So whenever I move forward, a key will be added here. Now I want to jump to another place of the map. Right now I have this. Maybe it's too fast also. So I'll just extend my duration here. To do that, let's just drag and drop this to the side, and we can increase this so we can this value so we can go further. Yeah, so here I'll put this key in 150. The next key will be someplace else entirely. Hopefully it just jumps to the other place, and then I'll move around to 200. Move around here, and at the end 250. I'll just be here, just as a proof of concept. So now when I press play, my camera, the rotation is going to another place entirely. Okay, but not to worry, because here in the previous frame, which is 50, this is 51, I can go back a frame like this. Whoop. What I will do is rotate the camera to where it should be looking towards, and see if there is a rotation there. I'll try to zoom in. Here, I'll just add it. And now it should be working. With control and dragging your mouse wheel, you can get the same result as I did. So I have something like this when I lose. It's not the best, but you get what I'm trying to do. Or I hope you get it. The way you can do jump cuts, and we can probably do more tutorials on it later, it's by creating another sequence and putting sequence inside other sequences. That way you avoid this issue of just jumping one of those type of transitions. Yeah, so you can avoid that like that with sequences. And I do need to increase this camera cut. So whenever I press play, I'm seeing everything. And that would be it. For now, let's just save it. Let's just close it. And in our racing game, here, whenever we finish the game, we already have a way of checking this. So we are going to play. If it's win, well, we'll play the win sequence. And when we lose, we can put this here, lose. And we need to find our actor sequence again. Where is it? Level. Here it is. Lose sequence. Tag it. Lose. Whoops, that's not lose. Lose. And whenever we lose, and I'm going to go to the game mode, and the start timer duration will be 2, so we lost. So we lose very easily. Play it. I need to cross this. I have 2 seconds. I lose. And we're not playing the cinematic. Excellent. So what is happening? This code, where is it? Am I finding it? Oh, I did not connect it. Okay, so now let's see if I'm losing correctly. Now, you lose. Here we should also have the losing cinematic, well, the losing menu. And in the case of the lose sequence, and I'm going to delete this tag, I want to loop it. So loop indefinitely. Play rate could be a lot slower, so I'll just put 0.5. And I also need the UI for that, so I'll just duplicate this. This will be loose screen. And I'm duplicating, but I could have used the same one. This type of loose. I could have used the same windscreen, but then I would have needed to change the value of this uwin depending on the game mode state. But by duplicating, I can just change it like this. U loose. And that's pretty much it. I just need to compile, save, go to my, where is my game mode, and add the same code that I added for the win, but also for the lose out of time. So it's the same code. Maybe I could have reused it here, but okay. I just want to finish this tutorial. It has gone too long for my taste. But we have covered a lot of topics actually. Didn't expect to cover that much with this one. And do remember to connect this. This will change to loose screen, which means that this button doesn't exist, but I need to create it again. Get button, I mean the reference, and just like that. So when we lose, I'll press play. I have seconds, need to run, you lose. And yeah, that's it. Restart the game and you can restart our little game. The tutorial should be finished by now, but seeing that I already created like the full game loop of a racing game, why not package it and have a richer tutorial or a fuller tutorial? So if you go to your racing game, right now I have closed Unreal, you can test how your game would feel in a standalone type of way, like right click it and launch it. This will start loading your game and you can see the performance and you can see how it's looking. So yeah, some things need to be rebuilt, and there we have it. We have our game and it should be working like inside of the engine, and I just remember that this is with a value of 2, right? So if we restart it, then we're fine. So well, you need to close it with Alt F4 because I didn't add the input key escape to close the game, so maybe we could add that also. So let's package it. And yeah, I crashed when I tried to to launch it while the engine was open. Okay, so first thing first, let's open the game mode and let's increase it back to 10. Start time and duration 10. Perfect. Let's go to my pawn, which is the sports car pawn, and I'm going to add the key quit. Project settings here, input, action mappings, add one that says quit, and the key will be escape. We already know how to do this, so we are just applying what we know. Here I'll just type quit game. Wasn't the one that I was trying to search, but this is my action event quit. But this is the node that we are going to use in order to quit the game. And quit. That's good enough. Perfect. Now we know now we have created a way of quitting the game by pressing escape, and that should work also whenever we package our game or we run it in standalone mode. So let's save everything. Let's build everything. Yeah, build everything. Save everything. And then we will package the game. And I'm building this because I had a little message here telling me that something was not built in the level, so that's why I did it. Okay, so I'm going to close this, and to package our project, I'm not going to do it this way. Oh, it's no longer here. Settings and packaging, no longer here either. Okay, well, I don't know even where it is here. Maybe it would be here, package project, because I really don't use this way of packaging. What I do normally is go to the project launcher, and in my project launcher create a custom profile, and here any project is fine. Build, development is fine. It could also be shipping. Let's just put it in shipping because let's say that this game is finally finished. So this is shipping. I don't need anything from this tool of Unreal. Cook, not on the fly, by the book. That way, whenever we start the game, we don't need to see how these shaders of the trees are being compiled. Platforms, I need to choose Windows. Cooked cultures by default should be English. There it is. The maps that I'm going to add, I only want this vehicle example map. DLCs release, don't need it. Advanced settings, I do want to compress everything to a single pack, so let me search for it. Store all content in a single Unreal pack, and yeah, that's good enough for me. Cook or build, shipping. Packaging, do not package, no. Package and store locally, and search for a place where you can put your stuff. Yeah, and be careful if you already have some stuff here with the name Windows No Editor, or with the name Windows. I'm just deleting everything there because I don't really use it. Build, select folder. Distribution for public, yeah, let's just say yes. Include an installer. This is very useful when you're making any type of friend that is not a game developer try your game. When you add this, your packaging size is greater, but it has the added bonus that if some prerequisite is missing, it will install it. So I'll just put it here. If maybe you want to share it with your family, I don't know. Anything here? Nah, nothing. Do you want to archive? No. Copy to device. What this will do, I don't need to copy to any device. So do not deploy. If I wanted to copy it to a cell phone or another PC, I could do it through here. And launch, well, if you are not deploying, then it cannot be launched, right? So if it was copy to device, you can select here how it will be launched after this is packaged. But in my case, do not deploy. Let's just save us some trouble. The profile name will be shipping profile, because everything here is in shipping. Shipping gets rid of a lot of debugging tools, so it increases your performance. It decreases the overhead when you need to load your game. So that's why I put everything here in shipping. So let's go back, and now we can start the packaging. So launch the profile, and it will go through these steps. First, you need to build the game. Building the game means compiling the code. If you are not devising some blueprints to C++, it will do it here. And if your game fails in this stage, it's because there may be a error in the logic, or a file may be corrupt, or a reference was missing, something like that. Here I'm going to allow the access, so it can use the cooker. It can generate the lightning if I was using some static lightning. Just accept everything that Unreal gives you. So cooking the content means that we are transforming these U assets, because if I just right click here and show in Explorer, these are U assets. A U asset is a binary file that we can use inside the editor, right? And we can modify stuff there. We can add code. If it's an static mesh, we can create collisions in it. But a .u asset is not a file that can be recognized but by other software or other hardware, right? So it doesn't make sense for these files to stay as U asset. Not only because they will not be able to be read, but also because, well, it takes more space, the fact that you can edit it. And if you can edit, then it means that change can happen, but we don't want really our customer or our player to change anything in the game. Right, so cooking the content means that we are converting those U assets to files that our hardware can recognize depending on which is the target platform. In our case, it's Windows, but it will be different if we were targeting a console or if we were targeting a different operating system. So a good example is the audio. The sound effects, I don't want it to be a .u asset. I want it to be .wab or wave. Sorry, my Spanish slips out sometimes. So .wab, wave, or maybe an MP3, I don't know. It makes these U assets smaller and readable for the target platform. That's basically it. Also, it applies some compression, so the packaging size is a lot smaller. Now, if your packaging fails during the cook content part of the packaging, then it means that some asset was corrupt, or also that a reference was not found. It's kind of the same when an error happened in building, but building usually is a reference missing in the code. Here's a reference just missing entirely. So you need to be very careful, and we can see exactly what's happening here, discovering asset registry and doing some stuff. You can see exactly the steps that this launcher is taking. And also this cook content will get rid of extra content that we are not using. For example, LODs that we are not using, it will be removed. Maps that we are not using, that we already selected which ones we are going to use, are also not packaged. And any assets that are not referenced by anything will not be loaded. And something that I forgot to check here before launching this project launcher is going here in the project settings, maps and modes, and making sure that my game default map is the map that I want. Because whenever I open this game, I will use this map. Just take that in consideration. And that's pretty much what I have to say. Oh, also, don't forget the game mode also needs to be there. Yeah, and that's all I had to say about packaging. I'll just pause the video, and when this is done, usually cooking the content is the most consuming thing. So when this is done, I'm still packaging, but I forgot also something important. Maybe if you launch this profile, you will fail here at the start build game. And it's not only because there could be errors in the code, but it's also because you really need a compiler. So you would need to install Visual Studio. An easy way to install it if you don't have it yet, let's just put file, and do it before you try to launch this. You put file here, or where can I create a C++ class? Here, in tools. Tools, new C++ class. If you don't have Visual Studio added, or any type of C++ compiler that Unreal can use, it will ask you to install it here. There will be a little banner that says, oh, you don't have something that we can use to create C++ or to develop in C++, installed here, and there's a button like here. Just click it, and that installer already have the selected components that you need in order to develop stuff in C++ and also to package a project. And it seems that it's still packaging. So yeah, that's the thing that I forgot to mention before starting packaging the project. And later on, also, it can show that you're missing some SDKs. You can search it online. You can also let us know in our Discord server. We can provide some support for that. And we also have I believe 3 videos on packaging that go more in depth. So yeah, let's wait for this to finish so we can open it and test it, and that would be it. Again, if this type of windows pop up, just allow access. And now we're in packaging content. The packaging is finally done. This is how long it lasted. And for sure it was a little bit more. Let's open it. Let's find the folder. And here it is, Windows. And inside it, we have the executable. These files, we really don't need them. You can delete them when you are sharing your file, your project. And this folder can be anything. So it can be called the name of your project, for example. Racing game. And I'll close the engine. Just like that. We can save this. And let's open the executable and see if it is working correctly. There it is. There's the engine noise. And it's still loading, it seems, like those materials. Or maybe it didn't load correctly. Let's see if we can finish the game. Then to fix the issues here, for example, is just saving the game again, checking that the material has all the needed assets, and there it is. Let's restart the game, and now we have our racing game finally done. And I opened the editor again, and this error popped up, which is saying something about the surface material of the spline was missing. So if the material asset is not resaved, it may not render correctly, which is what it was happening. So let's fix it. Yeah, so that should pretty much be it. I will need to do another package, like again, project launcher. We have that shipping profile here, and we just need to launch it like this. Now, the second time you package a project should be a lot faster. So it shouldn't take that much time, but sometimes if you are specifying a full rebuild, look there, the content was very fast. If you're doing a full rebuild, then it can take the same amount of time. In our case, it didn't. And yeah, this last part, packaging part, is creating and compressing the assets into our pack file and creating the folder structure that will be used when our game is finished packaging. So this time, very quickly, it was done. I'll close the editor again. I'll save this. And I'll go to my build. Is this it? Nope. To my builds, here it is, Windows. Let's open it up. And the surface still not looking right. So let me see what's happening there. Right, and I just couldn't live with that error. So what I did to fix it is go to the landscape. Here, not new, select the splines, all the splines. And why I'm not selecting the splines? Here's a spline. Where is the spline? Here is a spline. Here, all the splines. Now, all the splines should be selected. We are gonna update the spline mesh in all levels. And now we get this. Here, you will see, and this wasn't here. That's what I fixed. You will see here that spline meshes that we can use are here. Mesh. And instead of just dragging the materials on top of it, I'm just here going to create an override. The first one is these lines. So these lines were the damaged concrete, and drag and drop it. Now we can see the damaged concrete here, and a new override, which is the actual asphalt, this one. And why can I? There it is. There it is. And now we have it exactly as we have it before. We can go back to the select mode, save everything. And whenever we package it, and I already did it, so I don't waste too much time. I deleted the previous one. Remember, if you have a Windows folder here and you build on top of it, there will be some unforeseen errors, or maybe just a clear error that it didn't work. So now our packaged project, our project now has the materials that should have been there from the start. And now it is looking pretty cool. And with escape we can close the game. Perfect. That will be the end of this tutorial. Thanks for watching. And we have gone through a lot actually, from the project creation, defining the game, using the framework with the game mode and the pawn, modifying the car, optimizing. Well, we have been optimizing some things with this tool. These are instance static meshes. And we have polished a lot of the game. And it's not just a simple game. You can see that there is a little bit of polish that should make the experience a lot better. So hopefully you have learned at least something with this tutorial. And with that, see you in the next tutorial.